let's talk about like what things we are going to cover as a part of our content, how we are going to cover that, what books we are going to refer, and how we are going to actually, do the labs and everything. Topology, I will not explain you at the moment. Topology, I will explain you later on. But we'll just have just a general discussion, okay, about the things like the labs, the documents, and everything. There is no official content from the Cisco side that okay, these are the things that you have to cover. So based on a book that they have recently launched, not recently, I would not say recently, they launched this book quite earlier time. So based on the book that they have launched, I have made an index of the content that we are going to cover. I will share this book with you guys. Okay, it will be shared based on the same Trainonic portal. So once you join that, once you get the recording access and everything, you will get the access to that particular book as well. This is the official cert guide for the Cisco SD-WAN. Okay, let me show you that. This is the official certification guide for Cisco SD-WAN. What things we have to cover from the content point of view. Let's see this official cert guide as well. So what things are required for you to know in order to go through this SDA content. So first thing that you should know why we need SDA. The general use case of the software-defined access in your enterprise network. What solutions were proposed before the SDA? Okay, like when we did not have this SDA, what were the other options before the SDA? And how SDA came into the picture, what problems it resolves, what are the key challenges in a normal like day-to-day network, what are those challenges and all. So all those things are basically covered in the basics. Let me just show you the index. So this is the content that we are going to cover. The entire content has been like broken down into total 9 chapters. Chapter 1 is today's network and drivers for changes, like how today's network are designed and how like software-defined access SDA is going to change the way modern day network behaves. Introduction to Cisco Software-Defined Network, that is chapter number 2. So in chapter number 1, they have explored the problems in the traditional network, traditional campus area network, I would say. I would not say the wide area network, I will just say campus area network. Because remember, just to give you the idea, when it comes to software-defined solution for the enterprise network and for the data center, for example, there are total 3 things that you might have to study someday. For the enterprise network, we have like software-defined WAN, SD-WAN, and we have software-defined access or SDA. So SD-WAN and SDA, these are 2 things very popular for an enterprise network. I'm not saying we cannot use it in a data center environment. For example, you might also see SD-WAN routers on the data center environment. But these technologies are like a lot popular for the enterprise network. When it comes to the data center environment, we have ACI and EPIC. This ACI EPIC concept is already there. It has been there in the data center environment for a very long time, actually. Very long time. Like even before, actually, they created this EPIC, application policy infrastructure controller, for the data center environment. And from there, they got the idea that the same thing could be done for the enterprise networks as well. They created one EPIC EM. They created like application policy infrastructure controller enterprise module, which was a complete different thing than EPIC. EPIC was a different thing. EPIC EM was a different thing. EPIC was the controller for ACI implemented in a data center environment. And EPIC EM offering over there for the campus area network. So they created, they took out those fundamental parts from the EPIC and they created an enterprise module of that EPIC controller called EPIC EM, application policy infrastructure controller enterprise module. This did not go well actually. This EPIC EM companies, they adopted the EPIC EM environment. A few companies they used that product, but it was not very much popular. So in recent years, in recent 5 to 10 years, when the SD-WAN gained popularity, when the software-defined wide area network gained popularity, so what they thought, why shouldn't we actually repurpose, or why shouldn't we actually redesign this EPIC EM and launched it with a different name? So they took those core functionalities of the EPIC EM, which was already a product in a Cisco portfolio. Sadly, like not a lot of people, not a lot of enterprise companies were using that. If I say it was a disaster, it will not be wrong. Actually, a lot of companies, they opted that. It did not gain that much popularity as in modern day network. We have the SD-WAN, for example, because at that time, 10 to 15 years back, software-defined networking in an enterprise network was not that much of a big deal. Actually, people they don't even, they might not they must not have even been familiar with the Python coding and everything for the enterprise network and all. So EPIC EM did not gain a lot of popularity actually. However, when the SD-WAN started growing in the network in late 2019-20, Cisco repurposed this SDA. Cisco repurposed this EPIC-EM, and they created a new controller for the enterprise network to manage all the LAN devices from a centralized point, and they call that DNA. Digital Network Architecture, DNA controller, DNAC in short. I'm not saying that EPIC-EM is DNA. DNA uses like two core functionality. We'll talk about that. One of the core functions that the DNA provides, it is with the help of the EPIC-EM. So they just more like renamed, they rephrased, you can say, they repurposed the EPIC-EM appliance that they already had, and they created this DNAC, DNA Center Controller for the enterprise network. And recently it has started getting a lot of popularity. So we will be studying this DNA Center Controller as a part of our content. It is, at the moment, it is a hardware device only. So you can only, if you want to practice on this, you have to purchase the DNA Center appliance, and then you can do the practice on the same. Now, so we'll be studying this DNA Center. We'll talk about the components of the DNA Center and where exactly they have used this EPIC-EM in their DNA Center deployment. What part of the DNA Center handles this or is similar to this EPIC-EM controller that they already had. Okay, so you also have to remember for managing all the WAN edge devices, Cisco has an offering. In fact, a lot of vendors nowadays have offering called SD-WAN. SD-WAN is software-defined wide area network. It is a concept which allows us to manage all the WAN edge devices from a centralized point. All the WAN edge devices in your campus area network, in your data center infrastructure, those WAN edge devices could be deployed directly. Like, for example, this is a WAN edge router, this is a SD-WAN router connected directly to the internet, or they could be sitting behind a traditional router, completely fine. When you study the SD-WAN, you will see the deployment methods and all. But the point is, for the software-defined wide area network, they have an offering as well called SD-WAN. Cisco offers two SD-WAN. One SD-WAN is based on Viptela, and one SD-WAN is based on Meraki. So Meraki SD-WAN and Viptela SD-WAN, these are two offerings that Cisco actually has at the moment in the portfolio. Other vendors, Versa, VeloCloud, all the other vendors. So other vendors also have the SD-WAN offering as well. Almost every vendor, almost like a lot of vendors have the SD-WAN offering. But I've yet to see like any major vendor providing the SDA, like software-defined access functionality into their portfolio. So I would not say that Cisco is the only one with the DNA Center or with the centralized controller to manage all the LAN devices of your enterprise network. But if we there could be others as well. But at the moment, DNA Center is getting much more popularity as the others, if there are any. So in the first chapter, we will cover the same thing. We'll cover like why we what was the challenges in the traditional network, why we actually needed a controller to manage the traditional network from a centralized point. We'll talk about the challenges and problems of the traditional network and how DNA Center solves those problems. Okay, then what are the components and everything? So what is this SDA? What components are there in SDA? What problems this SDA solves? So that thing is going to be covered in the chapter number 2. Then we have Cisco's offering for the SDA. Cisco offers a DNA Center. So introduction to the Cisco DNA Center, Digital Network Architecture Center, DNA Center. So this DNA Center, they have explained quite well the architecture and everything, the components and everything. And from here, they will start the fundamentals of the SDA. So this was more like their product description. Okay, this was why SDA was needed. What were the challenges in the traditional network? And this right here is the, from here, we will start the in and outs of the SDA, such as, I will explain the content in very detail in a moment, just wait. From here, our SDA content will start properly. In a campus area network, we not only have the switches, we have, for example, access points as well, which are connected right here. We have some wireless clients connected onto this access point maybe. And this access point could be either, autonomous access point, or it could be a lightweighted access point. If just in case, if it is a lightweighted access point, this might have been managed via some controller called wireless LAN controller, WLC. So when we have to design a software-defined network for a LAN infrastructure, we not only have to consider the LAN, but we also we not only have to consider the wired, but we also have to configure wireless infrastructure in the design as well. DNA Center, point I was trying to make is that DNA Center in a campus area network, the DNA Center can be integrated with WLC. Like we can connect WLC to the DNS center, and we can manage the functionalities, or we can enable the wireless functionality in our SDA deployment using this WLC integration as well. The DNS center is one of the hardware appliances that you might need for the SDA deployment. The second component that you will need for the SDA deployment is WLC. Not necessarily, but if you have wireless devices, if you have wireless users, you have APs, you have WLCs, and you want to manage all of them from a centralized point, you want to enable the wireless in your SDA deployment, you can actually integrate WLC with the DNAT. We'll talk about the compatibility matrix. So different wireless LAN controllers are there, like different series are there actually. So based on which DNA version you have deployed, this compatibility is going to change. 9800 works fine. If you have a CL like a cloud-based 9800 series, that is fine. I have the same actually. I have already integrated and deployed that 9800 CL onto our DNS center, so that is working fine. But really, like when we talk about the SDA components, we'll go through the compatibility metrics, and then we will know based on which version of the DNS center you have deployed. There has to be specific iOS release that has to match. There has to be specific WLC controller that can be compatible with the DNS center appliance. And that that compatibility thing actually changes based on the version of the DNS center, which we will explore in the compatibility section, compatibility metrics section. And one more thing, the access points also, they have to be DNA compatible. Like you cannot just plug in any Air OS like old version Wave 1, Wave 2. There are some Wave 1, Wave 2 series of the access points that are supported. But anyone who knows about wireless, not all the access points are supported in the SDA deployment. Again, before you deploy the SDA into your fabric, you have to go to the compatibility metrics. You have to see which DNS center you got. And based on that, you have to see what switches are compatible, what WLC is compatible, what access point is compatible. In fact, when it comes to policy and everything, ICE is one of the most important component of the DNS center as well. So not only you need DNA, WLC, AP, but you also need identity services engine. Anyone who is in the security track, they must be familiar with the ICE. And just in case if anyone is from the security track, you must have noticed in the ICE version release 3 point something, they have changed the graphical user interface. If you have explored the ICE version 3, if you will notice that they have changed the graphical user interface of the ICE. If you explore the DNS Center version 2, if you explore the SD-WAN version like the 20.7, 20.6, 20.5, you will notice that they have changed the graphical user interface. They are making everything look similar actually. They are making everything look similar so that you don't have to like I will show you the graphical user interface of both. But everything will be like on the leftmost corner, every option, everything you can explore from here for the same, like for the ICE, for the DNAC, for the WLC, everything. So they are making the GUI look a lot more similar so that you don't get confused with those things. Quite honestly, I'm still using version 2.6, patch 7. So that's not going to be a problem. But we will talk about ICE. We'll not talk about ICE in very detail, as you might have expected, like it is not a security classes. So, however, what I will do with your content. So whatever things you needed to know from the ICE point of view, it will be there. The trainer will be Mr. Baldev for the same. If you want to study ICE, like you want to go through like deployment options, how many cores and everything, you have to give basics, fundamentals of the ICE. I will have that course integrated. We, in our content, will talk about ICE as per the content only. We'll not go through in detail of ICE. So chapter number 5 focuses on ICE, which is policy plane, for SDA. ICE is the policy plane for the SDA. So all the policies that we have to deploy, like for example, a user tries to SSH to the switch. I want that user must be authenticated via ICE. So I can integrate ICE and DNS Center. Of course, that DNS Center is managing the switches. So when any user tries to log into the switch, request will be sent to ICE first. Same process, authenticator, authentication server, and everything. The same thing that you might have studied in your security track. Same process will happen, and ICE will authenticate that user based on the credentials. Either that user will be allowed to SSH or it will be denied to do the SSH. Okay, but we will do that. Don't worry about that. ICE is also one of the component that is needed for this SDA deployment. Chapter number 6 is going to focus on the operations and troubleshooting of the SDA. which is going to cover more like, the different types. How can we configure different types of nodes, such as edge node, control plane node, border node, external border node, internal border node, different, SDA of LISP, VXLAN in detail, all those troubleshooting options and everything. We'll talk about that in very detail in our chapter number 6. Chapter number 7 is going to cover some advanced SDA topics, maybe the fusion router configuration, route leaking and everything. Those concepts are going to come under the chapter number 7. Chapter number 8 is going to cover the advanced options in the DNA center, such as different workflows. For example, you are a new guy hired by a company, a DNAC, and now your admin has asked you to establish an IPsec tunnel from one of the branch to another branch, and you actually have no idea how to build the IPsec tunnel. Okay, you don't even know what is IPsec. You just know that it is IPsec. IPsec is used to provide the security between the branches when we send the data. So our DNS center actually has a dedicated workflow. Our DNS center actually has a dedicated workflow. If you follow that workflow, you only have to define the branches, branch 1, branch 2, between which you want to create the IPsec tunnel. You have to define the parameters, and it will dynamically do all the configuration. It will push all those configuration onto the devices, and your IPsec tunnel will start working as well. In the advanced Cisco DNS Center, we'll explore different options that are available in our DNS Center. And at the very end, we'll talk about management. Assurance, basically monitoring and troubleshooting. So all the day 2 operations, creating the users, monitoring the health of the network, monitoring the health of the clients, a wireless user, wired user, everything related to the monitoring goes under this. So there are total 9 chapters, which could have been reduced to only 4 or 5 chapters. But anyway, there are total 9 chapters that we have to cover as per the official. In detail, if you want to know about those chapters, this is network of today, common business and IT intents and everything. So this is today's network and drivers for changes. What is SD-WAN? What are the component? What things we can manage from ICE, device administration, guest access, profiling, BYOD, integration with the PX grid. How can we actually enable the PX grid services onto the ICE so that the DNS center can integrate with the ICE? So design considerations and everything. This chapter number 2 introduces the SDA offered by Cisco. ICE deployment option, standalone deployment, distributed. See, it all is completed in one page. So we'll cover only this much. I'm not going to show you how to deploy the IEs and everything. That is not a part of our content. Okay, it all is completed in one page. So you have to cover it like it is done in one page only. The trusted functions, classification, propagation, SXP protocol and everything. We'll talk about Cisco TrustSec as a part of our content. Again, in brief. Then the DNS center. What is DNS center? History of the automation tool, what they had earlier, what they have now, how the wired networks is managed, how the wireless network is managed and everything. So that is there in the chapter number 3. Chapter number 4 focuses on the core concepts of the SDA, like underlay, overlay, how to create the underlay, how to create the overlay. For example, you have a shared data center. How can you actually leak the routes from the data center to the SDA branch, from the SDA branch to the data center and all? How the SD-WAN comes into the picture? What type of transit network can be there to enable the communication from one SDA branch to the other SDA branch? Is it going to be IP based? This is going to be SDA based. How to create the fabric. Basically, this chapter number 4 focuses everything that you need to know from the SDA fundamental point of view, like conceptual point of view, everything they have covered here. Device roles, control plane node, fabric border node, automation, control, like edge node, intermediate node, external node, fusion router, authentication, host onboarding. Any user, when it tries to plug into the switch, it has to be automatically authenticated by ICE. And it has to be assigned to with an IP address and everything. So that thing we can do on here. Then they have discussed a lot about ICE, like what is ICE, what things are there in the ICE, what type of certificates are there in the ICE. We'll just go through in like basics of the ICE as a part of our content. It's more theoretical, less practical. So we will just see different options available in the ICE, and then we will close this section. Main thing that we have to talk about in this ICE section is how ICE is being used as a policy plane for the SDA deployment. Basically, how we can use ICE for things such as micro segmentation and macro segmentation. Basically, restricting the communication between, let's say, 2 departments and restricting the communication within the department. In one case, we will require VRF, which is also referred to as VM, virtual network in terms of SDA. And the other thing that we require is called SGT. Security guys might have heard of this with the name of security group tags. But in Cisco SDA, we call them scalable group tags, because those tags are not only there to enforce the security, they can also be used to enforce the quality of service in your infrastructure as well, based on the. So we'll talk about that. How can we do micro segmentation, macro segmentation, authentication templates, what authentication options are available for wired user, for wireless user, how to integrate .1x, MAB, all these options we will explore actually. Okay, so this is going to be chapter number 5 is going to focus purely on ICE. Then we'll talk about LISP, VXLAN. We'll talk about how the HCP works in the SDA. We'll talk about how the wired client gets authenticated in the SDA, how wireless client gets authenticated in the SDA, basic troubleshooting, authentication, and all those things is under the operations and troubleshooting. This part we will cover actually way before the other parts. Like this thing we will cover at the beginning itself. What is LISP, what is VXLAN, and TV and everything, we'll talk about that. Chapter number 7 is going to focus on advanced SDA concepts such as extended node, what is the use of extended node, how to do the configuration of the extended nodes are the switches that you have connected into the deployment where normal switches will not survive, such as some sort of a place where some sort of biohazard thing is there, or a very rough place where we don't actually where we cannot actually deploy these normal 93, 9400 series switches, 9200 series switches, because they will not survive for a long time. So they have created those specific switches that can be used as extended nodes in those type of deployment where conditions are rough, such as maybe some R&D centers, such as biohazardous area and all. So there we use the concept of the extended node. We'll talk about that. How can we communicate the communication for the guest users, and how can we enable the communication for the normal LAN users? How multicasting works, multicast flow in the SDA, PIM sparse mode, PIM dense mode, what options are available, any source multicast, source specific multicast. We'll talk all about that as a part of our content. Okay, so this all comes under the advanced concept, design configurations, deployment configurations, like manual underlay, automated underlay, all those things, they go under this advanced Cisco Software-Defined Access. Under the advanced DNA center topic, we have the like scalability, migration, okay, templates, plug and play services. There is a concept called LAN automation in the DNA center, which allows us to configure only one switch, and all the rest of the switches will be discovered automatically and will be onboarded onto the fabric automatically. Whatever policy and everything you have defined prior to that onboarding can be pushed right away. So we'll talk about that. So these are some advanced topics where we talk about scalability, high availability. We talk about plug and play services, and we talk about different tools that we can use in our DNA. Assurance is going to focus mostly on the day 2 operation, template deployment, analysis, client health, overall health, network health, application related health, packet capture, path trace, if you have deployed different sensors, sensor analysis and all. So all those things, they are going to come under the assurance section. So there are in total 9 chapters that you have to go through. As you might have guessed, I'm not going to go through this book page by page. That's your responsibility. I have just shown you what content we are going to cover. Now it's your responsibility. As soon as, for example, we are done talking about the modern day network and everything. So it's your responsibility that you go through this chapter. Then we talk about the SDA. It's your responsibility to go through this chapter. This official certification guide will be shared with you guys on the same portal, Trainonic portal, and you can practice from there. You can read this book from there, and a certain topic is not covered, or any doubt if you. So this was actually how the content is going to be covered. This is from the content point of view, these are the things we are going to. I also have one PPT that we'll be using in our content, and this PPT will also be shared with you guys onto the same portal, so you can practice based on this. Just key points are here, so it's not like it's not going to include everything, and this is just includes the key point, so you can actually go through the topics that we have covered on regular basis from here. So these are the labs that we are going to do. So I will first of all give you the access. I will give you the overview of the DNA center. Okay, then we'll talk about hardware installation. We'll talk about hardware overview and installation, day 0 operation, role-based access control in DNA, ICE integration, preparing the DNA center and ICE for integration. There are certain settings that you have to do if it is not visible to you guys. There are certain settings that you have to do on the DNA. There are certain settings that you have to do on the ICE for this integration to work properly. So we will prepare our ICE and DNA center for integration. Then we will do the integration practically. Then I will explain you the topology that we are going to work on. Then we'll do some initial configuration on the topology. first discovery of LAN devices, creating a site, assigning the network settings for us. So first of all, we will create a site, for example, I-MEDITA Pune, and we will define the settings for that site. Like, for example, who is going to be the authentication server for that site, like who is going to be the AAA server and everything for that site. DHCP settings, wireless profiles and everything we will define here. Then we'll create the IP address pools. We'll upload the images in the image repository. I can mark those images as the golden images. So if any device on your network does not has that golden image, the DNS center will download that image for you and install it onto your particular device. So we can mark the images as the golden images, and we can install it on. We can upload it on the image repository. Then we will assign and provision the devices into the branch. Once we have defined all those settings and everything, then we will assign those devices into the branches. Then we will see how the segmentation works, micro and macro. Then we'll create the fabric sites, fabric domains, define the role. Okay, this device is the edge device. This device is the border node. This device is the control plane node. We'll assign the roles for the devices. Then we'll do the host onboarding. We'll reserve the pools for scalable groups. We'll create the users and policies on ICE for our administration. Then we'll talk about LAN automation, interacting with the here we will have a different topology. So there I will explain you, like I have a traditional network, like based on classic devices, and I have our DNA. So I will show you how the integration works with the DNS center. Creating a like transit network for layer 3 handoff. This is part of this topology configuration as well, fusion router configuration. We will have our most of the wired part completed. And then we'll talk about the workflow, such as assurance workflow. We'll talk about some other workflows, interacting with the DNS center APIs. Wireless, we'll talk about compatibility metrics and everything. How can we discover the wireless LAN controller into the network? And what configurations will be done by the DNS center for wired and wireless network. These are, I'm not sure how many labs are there. I did not name all of them. But these are approximate number of labs that we are going to cover. How many are there? 30. Approximately 30 labs we are going to cover as a part of our content. They are going to be very small labs. It's not like we are going to give 1 day for the entire lab. In 1 day, we might be able to cover 2 or 3 labs. So these are very small labs. So overall content will not take a lot of time, actually. Maximum, 6 to 7 weekends, maximum. It will not take more than that. No matter how much we stretch it, it will not take more than that. So from the lab point of view, this is the content that we are going to do. This is the order in which we are going to do all the content. This list will also be shared to you guys on the same portal so that you can keep a track, okay, that these are the topics that we have to go. But again, like I said, all these labs will be done by me. If you want to do the same labs, you can explore the dCloud, you can explore the Cisco Sandbox. But like I said, you will not be able to get the access on a hardware DNS center appliance from here. At the moment, it is not possible. You can have a discussion with, again, Mr. Sugandha or Mr. Saurabh, and they will tell you exactly how those things. There are a lot of challenges that you might face when you're deploying the traditional network that are related to the deployment itself. Like, let's say, you have your infrastructure up and running. You have approximately 50 to 100 number of switches, a few routers, 10 to 20 routers. You have some 5-10 WLCs or 5-10 APs and 2-3 WLC or 2 WLC, for example. You have all that in your infrastructure and everything is working fine. Maybe for your 10 to 20 sites, everything is working okay. But now what you have to do, you have to expand those 10 to 20 sites to, let's say, 50 to 100 sites. Your network growth happened so much that you need to have a few more sites deployed all around the world. So whenever we talk about a new deployment, switch deployment, or a new router deployment, a new firewall deployment, all the configurations we might have to do on those switches, routers, firewalls, APs, WLC, basically those switches have to be provisioned before they actually get deployed onto their network. We have to, for example, create the VLAN, we have to create the SVIs, we have to solve the STP related issues. We have to do a lot of manual, a lot of manual overhead will be there, a lot of manual configurations. A lot of manual troubleshooting will be there whenever we have to deploy, for example, new. So there are going to be challenges related to the new deployment. Whenever we deploy a new device, a new branch, for example, the devices that we are going to deploy onto those branches has to be provisioned by someone administratively. And now maybe we have deployed a router onto the border. We might have to configure BGP with our MPLS service provider. We might have to configure default route for the ISP. We have to configure routing protocol for the LAN, redistribution, a lot of things. We have to ensure if we have multiple routers, routing loop does not occur and everything. We had to do a lot of troubleshooting just in case if you have deployed more than one device onto that site. So there are a lot of challenges that you might face regarding deployment. There are a lot of challenges you might face security as well. There will be a lot of challenges based on security. So for example, like you have a new branch set up and on that new branch, you have enabled accidentally because of human error, you have enabled, for example, direct internet access for all the LAN users. Earlier, what was happening, the internet was being provisioned via data center. So data center router was giving a default route. That default route was received by that branch router. And everyone in my LAN was using that default route to send all the traffic to the data center. From the data center, there was a firewall. From that firewall, IPS, IDS, all those different security appliances were there in the data center. Traffic used to go from those appliances. Maybe the traffic is allowed to go to the internet. It is not allowed to go to the internet. So we had some sort of regional internet access, or we had some sort of central breakout for the internet. Why we had that? Because let's say we have 100 branches. Let's say we cannot possibly install a dedicated firewall on every branch. We don't have that much of budget. Maybe we are a growing company and we don't have that much of budget that we can deploy a dedicated firewall, UTM device, or dedicated security appliance onto the particular branch. So one solution, we thought that we will purchase appliances, we will install those appliances onto the data center, and we will ask all the branches to send the traffic to the data center, and then the traffic will go towards the internet. So some sort of regional internet access or central breakout was there. Advantage was security. Security was very tightened, like here. Everything was going towards the data center. From there, it was being forwarded. Now, the point is, accidentally, when deploying a new branch, in a few branch, you accidentally forgot to apply the policy which allows this router to receive a default route from the data center to make the data center and branch reachable. You already had an ISP connection, and you actually put a default route to that internet service provider. So now what is happening? You did the netting and everything. So now what is happening? All the traffic is being netted locally and it is being sent towards the ISP. Central breakout, local internet exit, direct internet access. Accidentally, problem is, like, for example, we are having a few users that can exit to the internet locally from the device, and their traffic is not being inspected by any firewall, any security appliance. There is a lot of security risk in this type of deployment. So whenever we deploy a new branch, we also have to tighten the security related policies. Like you have to, you can create the VLANs to segment. You can create the VLANs to segment the departments. Like you can create the VLANs to segment HR department with the admin department. And then you can create additional, like, for example, so the communication will happen between within the devices in one VLAN, but it will not happen between two or more VLANs. So some sort of security you have improved there as well. What you can do, apart from that, what you can do, you can deploy access control list, ACL, to restrict like who can communicate to whom. Like you can have that access control list configured onto the devices for the same. Problem with the ACL is that in a typical enterprise environment, you might see an access list with like 5,000, 10,000 lines. And just in case if you made any mistake in that access list, editing that access list is going to be a very challenging task as well. So no doubt we have the options to enforce the security using VLANs, using access list, or other security policies we can deploy. But the challenge remains the same. All those things are going to be done manually by some administrator, which will impose a lot of administrative challenge. And just in case if the administrator makes some mistake, some human errors, something like that, you will notice that security problems you might face onto that particular branch. One challenge that you might face in a traditional deployment is related to deployment. One challenge that you might face in a traditional network is a challenge related to security. Oh, what about the wired and wireless network? What about we not only have wired networks in our infrastructure, but we also have wireless network in our infrastructure. We have wireless clients in our infrastructure as well. We have approximately 1,000 clients that are on the wired stations, but we have 400 to 500 clients that are on the wireless infrastructure, and they are roaming actually. They have joined with some laptop, they have joined with the mobile devices, and they are roaming from one place to another place. So how you are going to manage these wired devices, how you are going to manage these wireless devices, how you are going to create a policy, maybe a security policy, deployment policy for wired infrastructure, and how you are going to create and manage the policy to deploy the wireless infrastructure. So the point is, we can have different policies for the wired infrastructure. We can have different policies for the wireless infrastructure. Then again, you had to create the, for example, VLANs for the wireless infrastructure. You had to create the security policies for those wireless infrastructure. Again, administrative overhead will increase. So based on what type of infrastructure you have, are you having only wired infrastructure, or are you having a wireless infrastructure as well? Based on both, you can either, deploy wired policy or the wireless policy, or both, wired VLAN, wireless VLANs, or both. So managing all that thing, again, for individual devices, individual WLC, individual access point, individual switches, is going to be a challenging task. So based on what type of network you have, you will face different issues regarding the management of those types of network as well. And of course, operational challenges. A user in branch number 90 sitting in Australia location reports that he is not able to access a certain resource of the company using some VPN and everything. So this was a server located in somewhere in US, and the user says that I was able to access these resources yesterday, but now I'm not able to access those resources at the moment. And I did not do any changes. I did not make any changes onto my machine. So in a traditional environment, troubleshooting can take a long time. You might ask a few questions to that employee, and then you will come to the result that, okay, this could be a possible problem. This could be a possible problem. You will eliminate one, like you will eliminate the possible problems one by one. And then you will come to the conclusion that, okay, what happened actually, this device, when it got the IP from the DHCP server, it actually could not get the IP for the DNS. And that's why it was not able to resolve the host name for that server. And then that's why it was not able to access the resources. So there is something wrong with the DHCP, or there's something wrong with the DNS. You might do some troubleshooting. You will use your knowledge to troubleshoot these kind of challenges. The point remains the same. It will take time. T-shoot in a traditional network will take time. In fact, we had a dedicated section for T-shoot in our earlier exams, where the Cisco used to test the troubleshooting capabilities of the candidate as well. Now they don't do that. I'm not saying that it's because of the DNA. Go purchase a DNA. I'm not saying because of that. It's just the point that I was pointing out. There are challenges. One of the switch, actually, in that switch you have to perform a software upgrade. Okay, and that switch is running like an older version of the operating system, and now you wanted to upgrade it. You wanted to upgrade this. You are going to call the administrator onto that site. You will give him the image, then he will upload that image, then he will do the reboot and everything. A lot of operational challenges you might face like that. And do not even forget about the vendor. What if I don't even have Cisco in the entire infrastructure of my network? Is it possible for this DNS center to manage a non-Cisco device? What about we have different vendors in our infrastructure? We have routers from Juniper, we have devices from Juniper, Cisco, Alcatel, Huawei, HP, Dell. We have different devices from different vendors. And those different vendor devices give different CLI. They have different approach to give the CLI access, the GUI access. Then this troubleshooting, then this management, then this operational challenges, then the security challenges. Of course, they will increase as well if you have different vendor deployed into your infrastructure. Apart from these, a lot of other challenges could be there as well. Like apart from all these challenges, there were other challenges as well. Like software-defined access looks to solve these following problems. One is security or segmentation related. Same thing that we have talked about. Like we can either perform the segmentation based on VLAN, we can perform the segmentation based on ACL, but both VLAN and ACL is not a very scalable thing to use when it comes to security or segmentation. Okay, host mobility. There is a wireless user who keeps roaming. There is a manager, your manager. He goes to first floor, he goes to second floor, he goes to third floor. And on every floor, he connects his laptop via wireless access point. So how you are going to ensure that no matter if that manager goes to any floor, first floor, second floor, third floor, basically if the host is mobile, if the host is roaming, how you are going to make sure that the same policy, for example, same VLAN membership, same level of access, same set of resources have to be assigned to that particular user. So how you are going to deal with the challenges when the host is not fixed onto a location? In fact, the host is mobile. He's roaming from one point to that point. What about I don't even know the graphical user interface, or I don't even know the CLI of any device, but I'm very good with Python. I know Python very well. I know Python in general, and I know Python for network engineer very well. So I'm not very good with the CLI, and I'm not very good with the exploring the GUI option, but I'm very good with coding. So let's say, for example, we have to achieve a task. We have to, for example, do certain thing on hundreds of switches, hundreds of devices. We have to do some changes. For example, we might have to change maybe we might have to configure the DNS server information maybe on everywhere. So is it really okay to configure that DNS or any other information on all those 100 devices one by one, where we can just create a script for the same, and we can actually use any third-party automation tool, such as maybe a Postman, and that Postman, if it is allowed by those switches, that Postman tool can programmatically configure those 100 devices for a certain configuration. So how in a ever challenging, ever growing network, how we are going to integrate the automation and orchestration features for the network will not only save time, it will also save you a lot of money. Why? You know why? Because now we don't need 10 people. We don't need 10 people for device administration, device management. I only need 1 or 2 people, at least let's say 2, who are well versed with the programming. They can work on the scripts. They can work on the tools such as Postman. They know how the network integration with automation happens. And those 1-2 people, they will just be enough. They will be enough to manage all those 100 devices from a centralized point using those automation tools. Your devices that you have in your infrastructure must be capable of understanding those commands, those instructions sent by the Postman tool. We call those, API calls. We'll talk about that later on. As a part of our content, we'll talk about APIs a little bit as well. So those devices must understand, actually. Those devices must understand the different, they must be capable to interact with those third-party automation tools as well. Basically, we have to enable a few things there, and then it all will be okay. So it will not only save some time, but also it will save some resources. What about the network visibility? How, let's say a user is facing same thing. A user is facing some problem, and he said that I was able to access the resources yesterday, but when I logged off at 5 p.m., I went home and I came back in the morning in the 9 a.m. For example, I was not able to access that resource of my data center, and I did not do any changes. So what happened between that 5 p.m. to 9 a.m. actually? Who did what? How you are going to have a complete visibility of your network? How you are going to have the visibility of your network? How you are going to have the visibility for the client? How you are going to have the visibility for applications? Okay, this user is actually using like Facebook a lot, like more in office hours. So what we had to do, we had to block the Facebook access for that particular user. So which application is being utilized? Oh, there is one candidate who is just, YouTubing like in office time period. So I might have to restrict the YouTube access for that particular user for 10 days, 15 days. So in which branch, which application is being utilized more as compared to the next one? Network access, like network visibility, the user visibility, application visibility, how we are going to manage all those things from a centralized point. So these were some challenges. Apart from these, the operational challenges are there, management of wired and wireless networks are there, deployment challenges are there, a lot of challenges are there actually. So how you are going to resolve all those problems in an environment such as data center? In an environment such as data center, where the network is focused based on the application the data center is running, they already created a solution for the data center environment called ACI, application centric infrastructure. So whenever you study the data center track, you will notice that they have a solution to all these problems using something called ACI. And EPIC, Application Policy Infrastructure Controller, is the Cisco's offering to manage that ACI infrastructure from a centralized point. I believe they have launched a new version of the Epic as well, which again has kind of similar GUI, graphical user interface. So in the data center environment, this thing is going on for quite long time actually. For quite long time, they have this ACI Epic going on. So when things were going fine, when the management and all those challenges were almost not I will say 100%, but almost resolved, they thought like it's very good. This is very good. This API concept is very good. This Epic ACI concept is very good. Why don't we implement it onto the production, onto the enterprise environment? Why don't we enable the companies to manage the LAN and of course WAN from a centralized point? So why don't we create the same type of controller? Epic was the controller for ACI actually. So they thought like, why don't we actually create a controller for LAN and WAN? So they came up with the idea of intent-based networking, and they came up with the idea of Epic EM. So intent-based networking was Cisco's offering before SD-WAN. You know, if you study about intent-based networking, you will see a lot of concepts similar to the SD-WAN that they have in a modern day network. And Epic EM, Application Policy Infrastructure Controller Enterprise Module, it was a different offering. Epic and Epic EM are two different things. Epic is specifically for the data center environment, and Epic EM is actually for enterprise level. So they offered enterprise networks. They offered with this intent-based networking concept and Epic EM. These two solutions they offered. But you know, back in 2009-10, when this automation thing was not that much popular, it was there in the market, but it was not that much popular. People hardly know about the software-defined networking. More people were focused on CLI. This thing actually could not cope up with that with that time. Like at that time of the network, like at that time we had the network. These intent-based networking, Epic EM, they could not actually cope up with the requirements, with the use cases of those times like of network, or the network of those times actually. But when, you know, later on Cisco acquired Viptela. Cisco acquired Viptela. Viptela was a company who was offering the SD-WAN, software-defined wide area network, SD-WAN solution for the companies. They had their own set of devices, such as they had the routers called VH routers. They had the controllers called VManage. We had the controllers called vSmart. We had the controllers called vBond. So they had these controllers and edge device concept, and they were offering the software-defined solution for the WAN edge routers. They say that do one thing: all the WAN edge router that you have in your production environment, replace all those WAN edge routers with these VH router, and then from a centralized point, you can manage everything. You can push, for example, the OSPF configurations. You can push maybe, for example, some BGP configuration. Basically, you can do all the management. You can do all the management and deployment and everything. Centralized provisioning and management of all these WAN edge devices can be done via VManage. And they also had some other controllers such as vBond and vSmart. When we study about the SD-WAN, we'll talk about them. But the point is, Viptela was offering these like SD-WAN solution, and this V-Edge, V-Manage, V-Smart, V stands for Viptela itself. So it's Viptela Bond, Viptela Smart, Viptela Manage, Viptela Edge. So V stands for Viptela. And it gained a lot of popularity actually. It gained a lot of popularity. Viptela gained a lot of popularity because in 2014-15, things started evolving to the software-defined networking. Everyone was, focused on the software-defined networking. So at that time, when this company was just, growing, Cisco acquired this company, and they now had a new offering for SD-WAN, which was based on Viptela. So it was Cisco SD-WAN Viptela actually. And later on, like once the acquisition and everything was done, nowadays it's just Cisco SD-WAN. So all the documents and everything, it has been now moved to the Cisco side, not on the Viptela side. All the support and everything you will get from Cisco nowadays. Now, the best thing about this was everything can be simulated in the softwares such as EVE-NG. Everything can be simulated on the softwares such as ESXi, kernel virtual machine. Even if you know about Azure, AWS, like we can deploy these controllers, for example, in a virtualized environment. And we can, once we deploy these controllers and the edge devices in a virtualized environment, basically we create a topology as my company topology is. And I will try to find like, is this technology even useful for me or not? And once I find that, okay, this technology is very useful, I will, in fact, go for this. So since this was a complete, it can be deployed on the ESXi, it can be deployed nowadays, it can be deployed on EVNG itself directly. You can do that. So the companies, they adopted this. Companies, they actually, went ahead with this. They downloaded the images from Cisco. They actually created a lab. They tested it, and when they found out that, oh, it's a very good technology, there are constant updates, new features are added on regular basis, and everything, they thought okay, now we should migrate to the SD-WAN. So that's why in approximately 2017, 18, 19, 20, like I would say 18, 19, 20, or 19, 20, 21, 22, you must have seen a sudden growth in the software-defined WAN, SD-WAN technology. I still remember people joining the companies on this SD-WAN technology based on the knowledge, based on the fact that they know what is vSmart, what is vMont, what is VEdge, VManage. That's it. Whoever was taking the interview, they don't even know the technology much either. So if you know the basics, oh, welcome. We'll explore these things together. It was like that at that time, 2018, 19. And since there were constant updates, currently we have 20.8.1 version of the controllers and all. It has came a long way. So new features have been added. A lot of new things have been added. So it's much more reliable solution nowadays. And that's why a lot of companies, other companies, not only Cisco, other companies also offers like this Versa SD-WAN is there, Willow Cloud SD-WAN is there. I believe Fortinet and all the other companies, they also have the SD-WAN offerings as well. Very good technology to manage all the WAN edge devices from a centralized point. Was a solution for intent-based networking. But what about the LAN? SD-WAN was concerned with managing, deploying, provisioning these devices. SD-WAN does not care what is on the LAN. Okay, you will say run OSPF, it will run OSPF. You will say run BGP, it will run BGP. Here, but it will not manage this LAN device. So now companies started asking for a solution that can be used to manage the LAN infrastructure as well. Actually, Cisco already had that offering earlier, but no one was interested in that offering at that time. And they repurposed this EPIC-EM into a new controller called DNA. We have versions of the DNA. We'll talk about those versions. So DNA Center is a hardware appliance that Cisco offers. Instead of EPIC-EM nowadays, it is more like obsolete. They don't even offer that EPIC-EM nowadays. They offer this DNA Center. And this DNA Center appliance is hardware only. So if you want to even test anything, you actually have to purchase the hardware. And it's not very cost-effective solution. If anyone knows about the DNA Center, you might notice that it will go approximately around 35 to, a 40 lakh or 30 to 40 lakh, 300,000, like approximately this much to, more than that. You can also go for you can also go for that lower version of the DNA Center. So it will cost approximately 28 to 35, but it's way too much money. 30 lakh INR, for example, just to do the testing, just to test whether your current infrastructure is compatible with, or is this DNA Center offering is going to be beneficial to you or not. 35 lakh for a normal enterprise network is way too much money. That's why no one was interested in this type of technology when it was launched. But then Cisco created some, sandbox environment. They created some where you can schedule the lab and you can explore all the options of the DNA Center. You can create the fabric and do everything. Then they created the DNA Center on the D cloud as well. So anything you want to just explore, what options are there in the new version, what options are there in the older version, you can go for the D cloud. So now the companies have choice that they can use this sandbox environment, they can use this D cloud, and they can explore if this DNA Center deployment is going to be beneficial for the company. That's why nowadays, a lot of companies, they have actually migrated in the SDA, and they actually also are. A lot of companies are going to migrate into the SDA. Now everyone knows that there's a good users, there is a good advantage of using the DNA Center in the LAN environment. Now, DNA and ACIE has no dependency. However, as what I have heard, DNA Center can be integrated with third-party controllers as well. Not third-party, I would say. They can be integrated with, for example, VManage. Okay. So their long-term aim was that DNA Center should be the centralized point of everything for the LAN and WAN for both. Okay, that was their aim. And in the recent version of the DNA Center, you will see that there is an option that we can integrate our vManage and other systems such as IPAM, IP Address Manager. We can integrate our Cisco Stealth Watch, a lot of things. I will show you in a moment how the DNA Center graphical user interface looks like. And a lot of these third-party things we can integrate. But there is no dependency between DNAC and ACI. ACI is the Epic is still the controller for the ACI, and DNAC is the controller solution for the SDA, actually, software-defined access. So okay, fine. I have the vManage that can manage the WAN devices. I have the DNA that can manage the LAN switches. Basically, I have software-defined offering that can manage my entire infrastructure, LAN and WAN both. So once you get the disadvantages of using DNAC and for example, vManage SD-WAN into your infrastructure, you can safely migrate from the classic WAN to SD-WAN, classic LAN to the SDA. Now, a lot of challenges are there. In the DNAC. For example, you should know LISP. You don't need to configure it, but you should know at least a little bit about protocol LISP, locator ID separation protocol. You need to learn the VXLAN, not the VLAN, virtual extensible local area network. You need to learn the ICE. These are at least three main components that you will notice in the SDA environment. And don't forget about ISIS. Cisco recommends DNA Center will be able to manage all these LAN switches from a centralized point. But for that, this DNA Center must be reachable to those switches. So for this underlay, they recommend you run the protocol ISIS, because when you call Cisco Tech and you explain them a problem, that this is a problem I'm facing with my DNA, and when they take the access, they expect to see ISIS there, not the OSPF, not the EIGRP. You can create your underlay on ISI, you can create your underlay on OSPF, you can create your underlay on EIGRP, but it's recommended that you have ISIS. Are you actually going to replace, or are you actually going to remove existing EIGRP protocol that is running in your 200 branches, stable for last 10 years, last 5 years, last 4 years, without giving any problem, working very fine? Are you actually willing to take that risk to remove all those EIGRP related configurations from 200 branches and replace it with ISIS? First of all, train your candidates for ISIS, train your corporate employees for ISIS. At least they should know basics of ISIS. And what about if someone faces some issue, like you deployed the ISIS, you configured the ISIS in your company, they don't even know ISIS. Why ISIS? We'll discuss about that in very detail. When we talk about individual components, we'll talk about ISIS, why they go for ISIS. You should know about LISP. You should know about VXLAN. You should know about ICE. You should know about ISIS. Basically, you have to know about a lot of things before you actually, in fact, go for this, SDA deployment. Now, again, question remains the same. I personally know a few, companies who rejected the deployment of the DNA Center in their infrastructure just because they did not want to play with the stable EIGRP solution. But if you are willing to take that risk, let's say you are a service provider environment, you are very good with ISIS, for example, it's okay. I'm not saying that you have to know everything about ISIS. You just need to know the fundamentals, but at least you should know. If the ISIS adjacency is not forming up between the switches, what is the reason? You don't even know the full form of ISIS, for example. Then how you are supposed to do the troubleshooting on ISIS? You think it from the student's point of view. You go for CCNA, you go for CCNP, you go for CCIE. Typically, you start from routing and switching. Where is ISIS in the routing and switching? Nowhere. Go for service provider if you want to study the ISIS. That's what they say. That's what I say. So if you want to, be very, very good with the DNS Center deployment, at least a little bit of ISIS, ICE, VXLAN, LISP, you should know. Based on these challenges, these conditions, a lot of companies still don't actually go for DNS center deployment. Otherwise, everything is good. I will show you that it's very good. It's a very good solution actually to manage the LAN devices. In fact, nowadays it can be integrated with the VManage. So it's a very good solution overall, actually. They created this SD, like this DNS Center offering. Not everyone has migrated to the DNS Center at the moment. SDA, not everyone is using SDA at the moment, but sooner or later, SDA will be almost exactly the same as the SD-WAN. As soon as they launch that software-based, for example, DNS Center, once the companies deploy that DNS Center into their infrastructure on ESXi and all, they test out everything. And when they find, okay, it's a very good solution, it's worth spending money, 30, 50 lakh on the same, obviously they will go for the same. But who knows how long it will take. So it's better like that you should be prepared for this, that kind of thing. At the moment, it's not that much. Now, how can this SDA, how can this DNS Center solve all these challenges? To show you how that SDA is going to solve this, how this DNS Center is going to solve these challenges, I'm going to go to the dcloud.cisco.com. I'm sending this in the chat, just in case if you guys want to copy this link. Go to the Cisco, like dcloud.cisco.com and log in with your Cisco credentials. I will log in quickly. If it does not work in the Chrome, go for Firefox. It will definitely work on Firefox. But once you log in, once you log into this dcloud Cisco, click on this dcloud, click on this instant demo here, right here. Click on this dcloud, click on this instant demo, and just scroll down, either scroll down or search at the top. So from here, you can get the demo level of access of all the new offerings that the Cisco has. For example, WebEx, for example, this Nexus, ACI, and all those things. Meraki. Okay, we don't need to worry about that. ICE 3.1. Let me open this one as well. Okay, I will show you that they are making the kind of similar type of GUI. So I will click on this ICE. Okay, it will open the new tab. Forget about that. And I also have to search for DNA. So I'm not able to find it like that. So I will just go on the top. And right here on the catalog, I will search DNA. When I search for the DNA assurance demo on cisco.com, DNS Center automation and assurance. This is the specific version for the DNS Center that you can go for and test everything on there. So I will just click on, I will just check that. 2.2.3.4 is what we will be using. And this is 2.2.2.8. Okay, I will go for this one. I will click because this is what we will be using, 2.2.3.4. Now, here, once you click on that, click on that view, it will open this type of it will open the GUI. Here you have to log in. How you are going to log in? You don't know the user ID and password. So just do this. Here, just go to the related document section. Here, go to the DNS Center design and provisioning ideas. Go to this one. And what is the login ID password for this? So get started. The login ID is demo. And the password is demo1234. Okay, so I will log in with this on the DNS Center. Okay, I have logged in with that login ID and password. Now I need to also log into the ICE. So what is about the ICE? I will just click on back. I will just search ICE on the top and I will try to find the login ID and password for the ICE as well. Oh, I accidentally got logged out actually. And related documents. So I have logged into the DNS Center. It's not owned by me, it's by Cisco. Okay, so what is the user ID and password for the same? Getting started, get started. It should be same actually, I believe. Demo1234. Yeah, same user ID password. So I will log into here with the same user ID password as well. So now this is the DNS Center and this is the ICE. So if you take a look at the DNS Center, this is a centralized dashboard that gives you all the information, everything of all the branches, all the data center, everything from a centralized point. So for example, we'll explore these one by one, everything we will explore, but just for a quick view. For example, you get to know the global health, like how many network devices are healthy, how many clients are healthy, wired clients, how many number of critical issues, priority 1, priority 2, critical issues, how many number of sites you have created, how many number of network devices are there, how many number of devices are provisioned, unreachable, how many policies you have applied, how many images you have uploaded, how many network profiles are there, DNA licensed devices, 47 switches are DNA licensed, 14 routers, 41 access points, and WLC are DNA. I can go to the bottom, at the very bottom, and I can, for example, I can use this tool. I can go to the topology and I can get everything from here. So from which branch you want to take a look at the topology, for example, here. So you forget about that. Click on the global and click on here on the topology one. This is the map. This is the map view, and just click on this topology view and see. This is the entire topology that you have for all the branches, all the devices everywhere. You can just zoom in, for example. You can zoom in, you can click on the device. Okay, for example, you can define the role, at which role you want to put this device and everything. So point I'm trying to make is that we can actually explore, for example, the entire topology from a centralized point from here itself. So that was under the tools option. That was under the, at the very bottom, it was under the tools option. For example, you don't know how to create the IPsec tunnel. Okay, I will go to this workflow. I will click on that. I don't know how to create the site-to-site IPsec tunnel. I don't know how to integrate umbrella. I don't know how to create the virtual networks or anything like that. Access will be permanent. This DNS center is permanent. Okay, this is just view level. You will be able to do a certain changes, but not everything. So this is permanent. You can explore this as much you want. So just for example, you don't know how to create the site-to-site VPN. Click on this. Okay, this is a dialog. This is a wizard that will guide you towards IPsec configuration. Click on next. Choose your desired sites for creating the VPN tunnel. Okay, set the tunnel pool, IP addresses, set the parameters, pre-share key, and everything. Basically, it's more like a GUI approach to configure the IPsec tunnel. Okay, the VPN name, select the sites, device, interface. Select the site, device, and interface, and click on next. Only a few steps will be required. Then you have to define the pre-share key and everything. A few steps are required, and the configurations will be provisioned. The configurations will be pushed from the DNS center to those devices automatically. So this workflow that we have here, this IPsec workflow, for example, is one of the workflow that you have that you can actually explore for a variety of options. Okay, I have to actually, once you go to this IPsec workflow, it does not go back. So you have to go back like that. A lot of workflows are there. For example, you want to design a new site, you want to design a new settings and everything, you can do it from here. You want to create the policy. So I said, like when we deploy a new network, we face a lot of security related challenges. So I can provision all the devices to the branches. I can push all the necessary configurations onto the devices regarding security and everything right from here. These are the number of devices in my inventory. Okay, like total, how many number of devices are there? These are the total number of devices and everything. You get all the information from here. Then in a specific region, how many number of devices we have allocated and everything. So before even you get that device deployed onto that site, you can create a policy for the same. And this policy can be created based on scalable group tags and VM virtual network. So at the moment, 26 scalable groups, 21 ICE profile, stealth watch, host groups, and everything is completed here. You can define the policies. We'll talk about that in more detail. We can define the policy just like that. Okay, bring your own device, financial services. I want to enable the policy, and as per the policy, I want to deny everything. Change, save, and done. Bring your own devices to the financial services, done. Deploy. Deployed successfully, done. That's it. So now any user who is part of that bring your own device group tries to communicate with the financial servers, it will not be able to communicate with that. Basically, this is how easy it is to create the policies using this chart wise, this matrix wise place like here in the DNS center. It is there also in the ICE. So we can manage these things via either ICE or we can manage via DNS center itself. So ICE will be standalone. ICE will be like read only, and this will be read write both. Or I can do like reverse. ICE will be read write both, and this will be like read only. I can use both at the same time. I can use both as per my requirement, because at the end it will be ICE who will be taking all the actions and everything. So completely up to you how you are going to enable that. So point I'm trying to make that everything from device provisioning, checking the health of the network, how you have created the sites and everything you have here. how many number of sites you have created. These are the number of sites you have created. In this site, how many devices are there? What topology is this? This is the topology. Onto that particular site, this is the topology. Okay, you want to basically enable the wireless feature or some other features from here. You can just enable it right from here. So you want to check the configurations, you want to check the port channel, for example, you want to check the details, you want to check the compliance information, everything you can in fact check from this particular point. You can define the roles. That's okay. These devices are edge nodes where the end users are going to be connected. These are control plane node, border node. These might have integrated wireless options as well. That's why it says embedded wireless is also on. I can disable these features accordingly as per my requirement. We will do all that. We'll create this. We'll create a small topology, not this much big topology. We'll create a small topology based on the same, and we will explore all the options from this workflow. This is the design workflow. This is the policy workflow. This is the provision workflow, and this at the end is the assurance workflow. You can go to the tools, for example. You can go system settings. You can go to the system settings. You can perform the software upgrades from here. You can check the DNA center information from here. You can manage the users, roles, disaster recovery, everything you can manage from here. You can click on settings. Under the settings, you can connect different accounts, different external services, everything you can connect on here. For example, you can connect different Cisco external services such as umbrella integration, IEs, authentication tokens for maybe umbrella or some other portals. We can integrate the VManage, IPAM, WebEx, AI analytics. They are continuously improving. They are regularly adding new features on this DNA center so that more things can be managed from the DNA center. That's why it's going to be a centralized solution for almost everything. And now you see on the I was not able to log in actually. Not sure why. Anyway, I'm not able to log in into this ICE, but if you log into the ICE, you will notice the same type of graphical user interface they have now for the ICE as well. So everything, you can see all the things, everything you can manage from this centralized device. All the LAN, in fact, since we can integrate this with the VManage, so we can also manage the WAN edge devices. We can pass the instructions to the VManage, and VManage will push those instructions to the other devices, other routers in your fabric. So these are 4 major workflows: design, policy, provision, and assurance. Apart from these 4 major workflows, we have some generic workflows as well, such as how to create the site-to-site VPN, how to integrate the umbrella, layer 2 VMs, layer 3 VMs, multicast, anycast gateway, how to create the, you are very new to the SDA and you don't know how to create the fabric site. So how to create the fabric site? You can just click on that and you can just create the fabric site. Okay, where you want to create the fabric site? I want to create the fabric site on Canada. Okay, click on next. Do you want, like, I will just say, okay, fine, create, and done. Then what you can do, you can add the devices into that fabric. You can add the devices into the fabric. Just for your information, you will not have access to everything. You will not have access to everything actually. Here, for example, you cannot assign the devices to the fabric because it's read only, it's not read write both. So certain things you can do, certain things you cannot do. But everything can be done from this centralized point. That's what I am actually saying. Yes, Napoleon, let me know.
Yeah, so that you have said, so that we can add the device. So that it means we need to add a serial number of the device.
No, just the device. Just the device. You already have that device in your inventory. You already have discovered that device, and all you are doing is just selecting that device. For example, let me just select one of the device, and I can just, like, for example, this device. I can say action. I can say provision, I can say assign to the site. That means this device will be assigned to that particular site. We'll do that practically so that you get better understanding of it. Fabric is a, at the moment you can understand that the fabric is a combination of both underlay and overlay. Underlay is the underlying infrastructure on the top of which overlay is created. It's like a combination of both underlay and overlay for the same. Discovery and everything will happen from the same. You can just go to the discovery can be done based on CDP. You just connect all those devices, use CDP for the discovery purpose. Right here, go to the discovery and you can discover the devices from here. It's kind of similar to Meraki, but it actually is having like a lot of like options as compared to Meraki or even the SD-WAN. It is equipped with a lot of things. So that's why, like, we'll explore as much as we can as per our content, and a few things you might have to explore from your side as. Napoleon, you have any question? You raised the hand actually, so
Yes, yes.
audible. Let me know.
Yeah, you said earlier Cisco IS is required to deploy Cisco DNA Center, right?
Cisco ICE is the policy plane for the DNS center. So once you integrate ICE with the DNS center, the policy and everything can be pushed via ICE to the switches to control which switches can communicate to which devices, can communicate to which users, can communicate to which users. We can use ICE in the infrastructure as well.
Okay. So for an example, so that where I have Cisco DNA Center, I'm just deploying a switch. I will be pushing the zero touch provisioning like that. Okay.
Yeah,
So
we can do that.
yes, so the policies of configurations will be from ICE to DNA Center
Yes,
and
yes,
from
yes.
DNA Center to
No,
switch.
no, no. It's from the, we will create the policy and everything on here. Okay. If your
Okay.
DNS center is being used as the policy plane, so here you will create all those policies here. DNS center will be the policy administration point. So you can control.
Okay.
You can control from here. You can control from here. Are you going to use DNS center for the policy, or are you going to use ICE for the policy? So if you use this option, that means you have to do everything on the ICE. But if you use this option, that means you will create and do everything under the policy section on here. And once you do that, that policy will be delivered to the ICE. And when the user tries to authenticate, or the communication has to happen, the ICE will be the one who will be responsible to check all those things. It's like integration. It's like talking. It's like DNS center will talk to ICE that, okay, these are the policy that I have defined onto the ICE, onto the DNS center. Take these policies. And if anyone tries to access the resources based on this policy, either allow them or block them. So it will be ICE who will be the policy plane for the DNS center, but we will be able to do all these configurations and everything, creating the scalable groups and everything on the DNS center. So we will explore all these workflows one by one. These are generic workflows. Then we have some other workflows as well, like these. I'm not going to explore all of them. A few of them we will try to explore, but not all of them. And then we'll talk about some device discovery topology. How can we check the topology? Like we can check the licenses on the devices and everything. We'll talk about all those things from here. In fact, we can also have API. If you are well versed with API, these are the APIs that you can actually use in the DNS center. They are properly documented. For example, you want to do site management. These are the APIs that you want to design a new site. These are the APIs that you can use to design a new site. Everything is documented properly. If you are well versed with API concept, you can explore these APIs and you can actually get the information, same type of information from the API response as well. I think I can, if try it out, it will just ask me the parameter, and if I say run, it will give me the result like this. Okay, so is there any task running? No, there's no task running. So we'll explore this at the very end. Actually, in the end, we'll explore these APIs concepts as well. We'll not do again everything, but we'll explore these few things from here as well. All right. So this has been like how what are the challenges that we have in a traditional network, and how, like what is DNS center, how the DNS center graphical user interface looks like, how can you access the labs and everything. This is all that. And now you can actually explore this from the website, from this Cisco website as well. We can actually continue from here. We'll talk about how the DNS center is going to deal with those challenges one by one, and then we will jump into the technical parts of the DNS.
All right, so let's talk about SDN. Let's talk about software-defined networking. What is software-defined networking? Why we use or why we need software-defined networking in our network? So before we understand the software-defined networking, that is the newer approach to manage the LAN and WAN infrastructure of any modern enterprise network. Let's talk about the traditional network. Let's talk about how we used to design the network in traditional cases and what were the challenges associated with the traditional network. So in the traditional networking, if you already know, the design typically follows either a 3-tier architecture or it follows a 2-tier architecture. From the 3-tier architectural point of view, generally we have 3 layers in the design. First layer is what we call as the access layer. Second layer is what we call as a distribution layer. And the third layer is what we call as the code layer. core layer can further be connected to the internet and the other outside the infrastructure devices. Now, we used to have like these devices, like we have one switch that is, let's call it access layer switch 1. We have one more switch, let's call that access layer switch 2. We have a few switches such as here, like distribution layer switch 1, distribution layer switch 2, and we used to connect it like in this way, like access layer switch 1 is going to be connected with the distribution layer switch 1 and 2. Access layer switch 2 is going to be connected with distribution layer switch 1 and 2. Here we used to have the end devices. They could be wired or wireless devices. We could have some sort of access points here from where we can have the wireless devices connected as well. We can have some like voice over IP devices, VoIP phones, and those things we can connect at the end. Now, if similar type of structure, this is, let's say this is in one of the building. If this is first building of some campus network, and let's say there is similar type of building here as well, distribution layer switch 1, or let's call that distribution layer switch 3 and 4, and we have like access layer switch number 3, let's call that, and access layer switch number 4. We have some users connected here as well. Now, if we have to connect these two buildings all together, what we can do, we can introduce a layer in between that we call as the core layer. So core layer switch 1, core layer switch 2, and we can connect like these devices with these core layer devices as well, so that our traffic can flow from one building to the other building, from one particular VLAN in one access layer device to the other like device in the VLAN on the second building. So typically our infrastructure is designed in this 3-tier hierarchical way. Some organizations, they don't have these 3-tier this 3-tier like hierarchy. They have like 2-tier architecture where we only have the access layer and distribution layer. The responsibilities of core layer were merged together in the distribution layer, and we used to call that some sort of core distribution layer. The responsibilities of, since core and distribution layer is merged together, so we used to call that core distribution layer. Now, in this type of topology, traffic like mostly follows from like south to north. It takes more of a south to north approach. Like the traffic is going to go from this machine to access layer device, from here to distribution layer. Then from the distribution layer, it will go to the, like if it has to go to the other side, other building, it will go to the core layer, from the core layer to the distribution layer to the access layer, and it will deliver it like right here. So traffic follows more of a south-north approach. Now, this is in a typical campus area network. When it comes to other places such as data center, the topology might differ. Data center traditionally, like they used to follow this type of architecture, but in data center, since data centers are designed to serve the specific type of services, specific type of applications, so in data center, more of an application-centric networking takes place. So the design from the data center point of view, it is not going to follow this 3-tier or 2-tier design. From the data center point of view, now in the data center, it is more of a spine leaf type of architecture, where we have some switches. We call them like for example, these are the leaf switches, like leaf switch number 1. Let's call that leaf switch number 2. Let's call that leaf switch number 3. Here we have the leaf switch number 4. Then we are going to connect them. We are going to connect these leaf switches with some sort of spine switches. Like let's call that spine switch number 1. Let's call that spine switch number 2. And we are going to connect it like in this fashion. Okay. So in the data, now here we can have variety of servers that could be based on the VMware or virtual devices. So we can connect our servers or all these devices on the leaf switches. And if I had to go from one of the leaf switch to other leaf switch, the traffic is again going to follow the spine switches accordingly. So mostly like in this case, the traffic goes more of like east to west type of. When the traffic has to go from east to west, this spine leaf type of architecture is comparatively better to have. Now, In both the cases, in both the networks, like in the traditional network based on 3-tier or 2-tier hierarchy, in this spine leaf architecture in the data center environment, if in the data center environment they were still using this 3-tier, 2-tier hierarchy, so managing the devices and infrastructure is going to be a little bit complex. So what they thought of that why not we overcome those issues that we face in the traditional network, and why don't we use some sort of software-defined approach to manage these devices that we have in our infrastructure. So what were those challenges that we are talking about? What were those challenges in the traditional networking? So one of the major challenge, one of the biggest challenge that you can have, it is going to be related to deployment of new devices. So let's say you already have your existing infrastructure consisting of like 2 or 3 devices, and suddenly your network growth happened, and now you have to expand your network to like 5 to 10 more devices. So you have to add 5 to 10 more devices in your infrastructure. Maybe you have to add some new switches, you have to have some new routers in your infrastructure. So what we have to do is that you have to, whatever configurations you have done on these 2-3 switches like VLANs and everything, you have to deploy all those things on these 5 to 10 devices, 5 to 10 switches if I consider as well. Like same configurations that you have done here, same like some users are going to be part of some VLAN, some users are going to be part of some other VLAN. Similar type of thing you have to do here as well. You have to configure few users in one VLAN, few users in other VLAN. You have to do all that thing. You have to install those new devices. You have to provision those new devices by yourself, and you have to then add new VLANs. You have to run the protocols such as you have to fine tune the protocols more like such as STP, or you have to fine tune the protocols such as VTP, DTP, whatever protocol you are running. So there were a few challenges based on deployment that you will face. Also, there were some challenges based on security. How security is provisioned in a typical enterprise infrastructure, it is, let's say, what we might do, we might create VLANs to separate the traffic for one user with the other user. We might have configured some sort of VLAN, and based on the VLAN, the traffic of one user cannot, go into the other VLANs. So this user cannot communicate with this user. Or we can have security based on something called access control list. ACLs, we can create like ACLs on the routers and the switches to prevent access of unauthorized users to the network. We can create the access list to block the communication between 2 or more devices. We can create the access list to block the remote access such as telnet or SSH from the unauthorized user to the devices. We can use ACLs for variety of tasks, in short. So we can enforce some level of security based on access control list. We can have a lot of security appliances as well. We can have like firewalls, we can have IPS, IDS, where we can apply a lot of security policies. We can have a lot of security policies, and we can deploy those security policies from that firewall or from that IPS, IDS device that we have. Now, what if if we are extending again, you are extending your network from 2-3 devices to 5-10 devices, and maybe you are adding a new branch. You might be adding some new branches in your existing infrastructure. So what you had to do, you had to create the VLANs, you had to create the ACLs, you had to add the security appliances onto that branch as well, and you had to enforce all those policies that you have applied here as well. So as the network grow, your ACLs they do not scale that well. I would say they do not scale that well. You can have like thousands of statements in the access list, and when it comes to management of that access list, it is not going to be an easy task. So security challenges were obviously there. Where we have to enforce similar type of security policies on all the branches, on all the departments. And what we had to do, we had to do that manually. Fine. We have other operational challenges as well. Like we had different types of operational challenges as well, such as, for example, let's say we are running a campus area network. In that campus area network, same we have like access layer, we have access layer devices, then we have distribution layer devices, and we have connected all these devices with like distribution layer switch 1, distribution layer switch 2, like that we have connected. And then further on it can go also to the core layer switches, like core layer switch 1, core layer switch 2, whatever. So here we might be facing some sort of operational challenges as well. For example, a user reports that I'm not able to get the IP address via DHCP, or my time is not synchronizing with the network due to some reason, or my DNS resolution, when I open the web page, I do not see that DNS getting resolved properly. So let's say if the user in VLAN 2 raises some sort of issue, a user in a particular VLAN 1020 raises some sort of issue, what approach you are going to take to resolve that issue. Let's say the user says that I'm not able to get the access to the I'm not able to get the access to the network. Why? Because I don't have the IP address. I was supposed to get the IP from the DHCP, but I'm not actually having the IP address right now. So what approach you are going to basically take to resolve this issue? You might check the DHCP server, you might check the reachability, you might check the, for example, if you have done the routing, you will check the routing protocols. If you are dealing with the spanning tree here, like you will see if the appropriate ports are blocked or not, if the loop is there or not. So once you eliminate all these possibilities because of which the packet can drop, you might be able to troubleshoot like what exactly problem was there. So you could face a lot of operational challenges as well. Other challenges that you might face is the management of the wired and wireless users. In modern day network, we don't only have the wired users connected in our infrastructure. We also have the wireless devices, wireless users connected in our infrastructure. So how you are going to deal with those wired or wireless devices in your network? Maybe we want to have some different type of policies. We want to have some different type of policy for the wired user, and we want to have a different type of policy for the wireless user. Okay, we want to ensure that any user that comes in our infrastructure and joins our wireless network is going to be considered part of as a guest Wi-Fi network, and we want to ensure that our guest users, they do not consume a lot of bandwidth. I want to ensure that our guest users, they do not talk with our internal like wired or the other users. I want these guest users to only have the access to the internet so that they can do their daily tasks, but they are not allowed to communicate with the other departments of my organization, such as admin department or the finance department or anyone. So the management of wired and wireless users is also going to impose some challenges. Other issues that you might face in the traditional network is some sort of vendor dependency. Not from the point of view of traffic flow, because since the TCP/IP came in the market, any vendor can communicate with any vendor. So I'm not talking about from the data flow point of view. I'm talking about from the vendor, basically device type point of view. So what if like what if I think like in our core, in our like access layer, what we should have the Cisco switches. These switches that we have in our access layer, these are the Cisco switches. And now I think like Cisco switches that I have applied here at the access layer or even at the distribution layer, I don't want to have the same Cisco switches on my distribution layer or at my core layer. I want to use a switch from some other vendor, and I want to connect it like this. So what if I do these all the switches that we have, these are like all the Cisco switches, and here we have some different switches. This could be any vendor like HP or any other vendor switches we can have. So in that case, like management, how you are going to do the management of these switches, how you are going to take the management level access of these switches, the CLI or GUI of these switches or CLI GUI of these switches is going to be completely different based on what vendor you are going for. So how you are going to manage these different vendor devices into your infrastructure. Not only Cisco, you can also have Juniper based devices, you can have HP, or you can have firewall that is not made by Cisco, you can have a for example, Palo Alto or Checkpoint, these firewall solutions you might want to go for. So how you are going to have management, how you are going to manage all these different vendor devices in your organization. So these type of challenges, these are some examples of the challenges that you might have in your infrastructure. So to deal with these variety of challenges based on security, to deal with the challenges based on these wired management of wired or wireless user, to deal with these challenges of variety of operational issues, or to deal with the challenges of these vendor dependency or vendor lock-in issue, to deal with these deployment issues, they thought of introducing some sort of a software-defined approach to solve all these. So software-defined networking, or SDN, is basically an approach that they actually took to resolve a variety of challenges that we had in a traditional network. And the software-defined approach to manage the LAN infrastructure of any campus area network or any enterprise network is what they call SD-Access, software-defined access. The software-defined approach to manage the WAN infrastructure of any network is what they called as the WAN. And even in the data center environment, if you're talking about data center topologies where we follow some sort of a spine leaf architecture, there also we want to have a centralized point of control using some sort of application-based networking, software-defined networking. So in the data center environment, we already had ACI for a very long time. So software-defined approach to manage the data center network, actually what they do that based on something called application-centric infrastructure, or ACIs. ACI was there in the data center environment for a very long time, uses the concept of VXLAN and the other to manage the data center environment. So ACI was there in the data center environment for a very long time. This software-defined access and software-defined WAN they introduced in our enterprise campus area network, so that we can have a centralized point of control. We can have centralized point of control over LAN and WAN, which is going to make all the like security related concerns, or it is going to allow us to manage all the devices from a centralized point of view. It is going to make the deployment of new devices very, very easy. Similar set of policies we can apply from one point to other point. It is going to resolve variety of operational issues as well, because anytime suppose a user cannot get the IP from the DHCP, the controller that we use in the software-defined networking, they can give us prediction, or they can give us like what could be the reason for this problem, and what could be the possible solution, what could be the steps that you can take to resolve this issue. They have that sort of dependency. Vendor lock-in issue is not going to be there. You can use whatever type of switches that you have, and that controller that we are going to use can talk to these devices, specifically like for example traditional devices that we are using which do not support software-defined networking, based on like telnet or SNMP or these type of things they can talk about. This vendor lock-in issue was resolved earlier by creating the controllers based on standards such as OpenFlow. So that was a standard that people like the organizations were using earlier, but nowadays like Cisco, if you specifically talk about Cisco, to provide the full control on the LAN infrastructure of a network, Cisco has this controller called DNA Center or DNAC. For the WAN solution, if you talk about the WAN solution, Cisco basically has the SD-WAN based on VipTela. Cisco also offers Meraki based SD-WAN. So we do have two SD-WAN solutions in Cisco. So Meraki based SD-WAN and the VipTela based SD-WAN, both we have in Cisco, which is just the approach of managing the WAN as devices in the infrastructure. And as far as the data center is concerned, ACI, application centric infrastructure, is already there. It has been there for comparatively like very long time. So to resolve all these challenges, we will see how or what actually what controllers are used and how these controllers are used to resolve all these issues. All right. So as we discussed, like in what exactly is SDN, is that it is software defined networking approach to solve the challenges that we had in a LAN environment and in a WAN environment. So in a data center network also we have that concept of ACIs. There they use different set of controllers to manage the data center infrastructure. Let's not talk about the data center environment. Let's focus the focus of our content is software defined access, which is a solution designed to specifically campus area network. In this video, let's first talk about what were the challenges that we used to face in the WAN and how the software-defined approach to manage the WAN infrastructure as the WAN helped us in overcoming those challenges. So in earlier days, when we talk about WAN was only and only about like connecting maybe a few data centers to the branches or headquarter to the branches. Like we have this headquarter, we have this branch, we have this data center, for example, we have some other branches as well. So WAN was all about connecting the different locations all together using any sort of WAN transport such as MPLS or internet. People, they were using MPLS as a main like primary transport, and they were using internet more as of a backup WAN transport. Over the internet, they used to use this DM VPN protected with IPsec. All these technologies they used to use to send the data over a public network such as internet. And MPLS is comparatively considered as a secure transport when it comes to internet. So since the MPLS services are not shared with anyone, unlike internet, anyone can access the internet. MPLS can be considered as a much more better or much more secure transport in comparison to the internet. From that point of view, that it is not publicly accessible. So companies, they can use the MPLS as their primary transport. They can use internet as a backup transport. All the traffic will go via MPLS. If the internet MPLS goes down, then only the internet transport can be used. Users, for example, like there is a user or here there is a user in a branch. If the user wants to access the internet, user, even though it is directly connected with the internet, it cannot access the internet services directly. It has to go, the traffic all the way might go towards the data center, and from the data center we have like different security appliances and all those things. Traffic might get inspected over those security appliances, and then internet is going to be provisioned from the data center. More like centralized provisioning of the internet services was there. Central breakout was there. Now, as the WAN technologies evolved, we started facing like a lot of issues in the WAN network. Like for example, nowadays WAN is not only about connecting your branches to the headquarter data center all to each other. It is about all the other things as well. For example, like in modern day network, a lot of services, a lot of companies, they prefer their softwares to be hosted on cloud. They opt for this software as a service model provided by a lot of cloud service providers such as AWS or Azure or even the Google Cloud. So nowadays applications or softwares, they are moving to the cloud. It could be a public cloud, it could be a private cloud. Nowadays internet is being provisioned locally onto the branch. Internet is basically moving to the branches, more like some sort of, we might require direct internet access for a few users in the branches. In today's network, the business that the company has is not only going to be limited to the computers, like static devices, like the devices on which the people are going to use these services. They could be like mobile devices. Like the use of mobile devices has increased a lot in past few years. Bring your own device concept, BYOD, bring your own device concept is very popular in a companies as well. For example, they could have a separate Wi-Fi for the guest users, and they are required to use that Wi-Fi to access the internet services. The apps that nowadays companies make, they are going to consume comparatively a higher bandwidth because the content of the app is very rich. It is dynamic, and it is more like web-based content. Not only uh, not only fixed devices, but the mobile devices are also going to access the services provided by your organization, for example. So a lot of new challenges got introduced because of these. Companies are also opting for infrastructure as a service. Company might not spend a lot of money or resources building the physical infrastructure, while they can go for the services or infrastructure provided by some, again, cloud service provider. There were a lot of challenges that they were facing in terms of WAN. Again, how about like if you have to extend your network, let's say currently you had like around 100 branches, and what happened, like the network expansion happened, and now you have to add like 50 to 60 more branches. You have to add in every branch, you at least have to add 2 devices. So total approximately, let's consider like 120 number of devices you have to add worldwide. How you are going to apply same set of policy on all these devices from a centralized point? Or even though if the same policy you have to apply on these new devices, someone has to do some sort of copy pasting thing. And even if doing on that copy paste, some configuration might be needed to change. So as your network extends, the management of the network gets tough as well. What about suddenly you got a new software release and you now have to upgrade that? That is a very stable software release. A few bugs have been fixed. So now what you had to do is that you had to load up that release on all these previous 100 branches plus these 50, 60 new branches as well. How you are going to perform software upgrades on all these devices? Like, are you going to do that by going to each and every device one by one, or are you going to do that from some centralized point? These type of challenges were introduced as the WAN technology got evolved throughout the time. Not only single cloud, but multiple clouds. Companies, they go for some services. Companies might get better on one cloud. Some services they might get better on the other cloud. Some services they might get better on the other cloud, Google Cloud. So companies, they might go for a multi-cloud environment in their infrastructure. So we need someone who knows this AWS. We need someone who knows this Azure. We need someone who needs this GCP. So point is, there are a lot of challenges that got introduced as the WAN got evolved throughout the time. Nowadays, it's not only about connecting your headquarters to the branches and to the data center, maybe with the help of the WAN technology. MPLS, for example, like here, the MPLS services that we are having, MPLS is not a very cost-effective solution. You have the MPLS option, MPLS as a WAN service to connect your data center to the branches, headquarters, and also, you know, it is not a very cost-effective solution as well. So to deal with all these challenges, they thought of using, again, the software-defined approach to manage these WAN edge devices. All the WAN edge devices that you have in your infrastructure, for example, in my infrastructure, I have this and these two are the WAN edge devices, and it could be any LAN infrastructure, I don't care. But these are two WAN edge devices which are connected with the transport, public transport such as internet, and they might be connected with the private transport such as MPLS as well. I want, similar to this, we have like 10-20 branches. We have like 10-20 branches, and in some branch we have only one router. In some branch I have two routers, for example, and I want to have a centralized control over all the aspects of these WAN edge devices. That sort of service we can get from the SD-WAN, software-defined approach to manage The WANs devices is what we get in the SD-WAN. I'm not saying that you go for Cisco SD-WAN. You can go for the other SD-WAN vendors as well. You can go for like VeloCloud, Versa, VMware, and the other vendors are there as well. Cisco also offers SD-WAN solution based on Viptela, and Cisco offers SD-WAN solution based on Meraki. So Meraki SD-WAN is there, Viptela based SD-WAN, both are there. You can, based on your requirement, costing, and everything, you can compare different SD-WAN solution, and you can opt for one if you want to manage like all the WANs devices from the centralized point. Let me give you a brief overview what SD-WAN does. In SD-WAN, what they have done, they have taken out all the intelligence of this device and they created some separate devices called controllers. So software-defined networking, SDN, software-defined approach to manage the infrastructure, uses some sort of controllers to have a centralized control everywhere. The controller that SD-WAN uses is what we call something called VManage. This is one of the controller that the SD-WAN Viptela based SD-WAN uses. So V stands for obviously Viptela, and VManage is the name of the controller that is there in the SD-WAN solution, which is responsible to do all the management task from a centralized point. You can say VManage is the centralized management plane of the device. Second controller that is there in the SD-WAN is something called vSmart. vSmart, you can say, is the centralized control plane. It is the centralized control plane of the SD-WAN. All the control plane intelligence has been pushed to this controller called vSmart controller. There's also one more controller called Bond, vBond. I was trying to make that joke for a very long time. So vBond is the controller that we have here, which is responsible to orchestrate the, we call that vBond orchestrator. It is what we call as vBond orchestrator. It is responsible to orchestrate the management plane and control plane functions to the edge devices. In short, vBond orchestrator is the device, is the controller that allows the routers to find their respective management plane and the control plane. Whenever the edge devices, the data plane devices, we call them V edge devices or the C edge devices. Whenever these data plane devices come online, these are the data plane devices. So whenever these data plane devices come online, they reach out to the vBond. Some sort of authentication takes place between these vBond orchestrator and the V edge or C edge device, Viptela based S device or Cisco based S device. In VS devices, we have Viptela operating system. In CS devices, we have Cisco IOS XE SD-WAN. So these devices, they reach out to the vBond. After some sort of mutual authentication, vBond is going to tell these S devices who is the vManage and who is the vSmart. Basically, vBond is the orchestrator which tells the S devices about their control plane and the management plane. So in SD-WAN solution, you will see the use of these three controllers. These are three controllers, and these are the S devices. S devices are based on V edge and C edge. Now we will talk about these solutions whenever we study about SD-WAN someday, but our content is focused on SD-Access technology, not the SD-WAN. So let me just give you a brief overview how this SD-WAN, how this VManage looks like, how we can do a centralized provisioning on all the WAN edge devices. Note that SD-WAN VManage is not going to manage the LAN devices. It is only for WAN edge devices. So what you can do actually, you can go to Cisco D Cloud. You go to the Cisco D Cloud. From here, you can, obviously you have to log in. So you log in. From here, you can choose the appropriate data center that is nearest to your location. Then you can go to the catalog section. Under the catalog section, you can search here for the SD-WAN. You can search here for the SD-WAN. You search here for the SD-WAN. And you will find like few demos that you can take for the SD-WAN. Make sure that here in the content categories, you click on instant demo. Once you click on that instant demo, you will see that this Cisco SD-WAN, Cisco Secure SD-WAN 20.6 with cloud integration instant demo, you can launch it from here. Okay, you can just open the related document here, like demo guide. You can open it on the side if you want, and rest you can just click on view. Okay, once you click on view, it is going to open cloud-based access to this VManage Network Management Station. Okay, so what Cisco has done is that they have given us the access that we can at least view what SD-WAN does, what are the advantages you will get SD-WAN based on this pre-configured lab. Now, here you have to log in and everything. So how you can log in? You can just, again, you can just read this document here. You can read this document here. You open this document, and here, once you scroll down, this is the topology. Open image in new tab. I will open. This is the topology that they are going to use. Okay, in the demo, this is the topology that they are going to use. This is one data center. We have two NS devices. Here we have one branch where we have two devices. When we have some IoT based branches where the IoT is being used, and basically few branches are there here as well. Okay, now these devices are VS devices, these devices are CS devices, and they are connected via MPLS and internet. All those things are there. So this is the topology. And if you scroll down, this is right here, you will see the demo user ID and password. You will see all these things here. So what you have to do here, if you have to log in, you have to put that same user ID and password. So you will put that user ID and password, and you can click on login. This is how the VManage Network Management Station GUI looks like. Wait for this to get load properly. So in a moment, you will see how the graphical user interface of VManage looks like and what things you can do from this centralized VManage. Note that the latest version of the SD-WAN is 20.7. They have given us the demo for 20.6. Here and there, a few functionalities might get changed, but rest are going to be same. So as you can see, this is the main dashboard. From here, you can get the idea of, like, for example, what are the top applications running in your infrastructure, like from what place to what place application specific routing, how it is being done, the health of the transport sites and everything, WAN devices, control connections, and all those things you can validate from here. It says there are 2 vSmarts connected, as you can see here. And on the controller side, they are using 2 vSmarts. There are total 8 WAN devices. There are total 2 vBond, 1 vManage. 2 times it has been reboot since last 24 hours, and all those things you can see from here. If you click on these WAN devices, you will see the list of all these WAN devices, like same WAN devices that are listed here. So, okay, here you will get other options as well. For example, you can open the SSH terminal, you can open the device dashboard, you can open the real time, all those things you can do from the centralized point. So we might not have access to everything because there is just a demo. So you might not be able to have the access to everything, but whatever things you can do on the real device, you can check everything from here itself. Okay. So for example, you can check the interface statistics and all those things you can check from the centralized point as well. We might not have access to all these things, okay, because of the reason that it is just the demo. Okay, so we might not have the access to everything, but it shows you all these things here. So for example, like it is showing me that there are gigabit 1, 2, 3, 4, all these different interfaces, administrative status and everything. What we have to do, show IP interface brief command we have to use for this output, and here we can just check it based on the GUI, MAC address and everything I can check. So this is just a demo. So we might not have the access to everything, but from here you can take a look at the different things, such as what applications are consuming what traffic. Then you can click on here. You can go to the this was the main dashboard. You can check the VPN dashboard. You can check the security dashboard. In the security dashboard, you can see how many times the firewall enforcement has been done for the traffic. So how many packets or how much packets got inspected by the firewall, how much packets got dropped by the firewall, and all those things in past 24 hours, past 1 hour, past 7 days. All those things you can validate from here. Top signature hits, URL filtering, AMP, advanced malware protection. So just in case if you have integrated some sort of security features, You will see all those things here itself. This is the security dashboard. Same like you have multi-cloud dashboard here as well. So if you are having support of different clouds such as AWS, Azure, or the Google Cloud, you can have all those things here itself. Now let me go here. From here you can do all the monitoring related tasks, like geographically you can validate what devices are connected there. All those things you can validate from here. Okay, like that. You see there are 2 devices here. So geographically, if you want to check the things, you can check it from here. Network specific things, you can check it from here. Device by device, any device you want to check, you can just click on that device, and everything related to the network you can check it from here. From the very end, deep packet inspection application, interfaces. Okay, so whatever things we have permission to, we can check, otherwise we cannot, basically. So interface status, all these things like packets, all in a single chart or different chart, we can validate all those things from here. A lot of things are there. You can validate, you can do almost everything related to the monitoring from the centralized point. Okay, then configuration. When it comes to the configuration, you can configure different things, such as you can configure the routing protocol such as OSPF from here in the format of templates. So if I search the template, if I click on the template, and if I search here OSPF, I might see that they have attached some OSPF templates in some sites. So there are total 2 devices where they have attached the OSPF template, 2 devices where they have attached the OSPF template. And now if I have to suppose run the OSPF in 100 more devices, all I have to do is that I have to attach the OSPF template to those 100 devices. I don't have to do the configurations of OSPF again and again. I can click on here and I can view, I can edit, all those things I can do. Okay, so but again, same thing, whatever things we are allowed to check, I can check, other things we cannot. So just take a look at that. We can do different configurations from the centralized point from here itself as well. This is just a demo. Now we can also configure different types of policies from the centralized point. We have like all these devices connected. I want to have some sort of hub and spoke type of policy. I can have hub and spoke type of policy. I can have a C-flood policy. I can have different type of policies applied from the centralized point. I don't need to have different CLI open to apply the policies. Centralized policy, localized policy. When you study SD-WAN, you will come to know about all those things. So you can apply these different types of policies from the centralized point. Fine. Different tools are there as well, by which you can take the SSH access, you can rediscover the network, operational commands, you can execute template migration. All those options are there as well. You can do the software upgrades and all those things from the centralized point as well. So if you want to upgrade the images, just click on here and upgrade. Basically, you have to upload the image. You have to first of all upload the image here. Once you upload the image, just like they have done, then what you can do, you can upgrade. You can upgrade the code of the, you can upgrade the image just like from here and click on upgrade. Just a single click and the background process will follow and the software will be upgraded up for that device. Then you go to the administration. Here you will see some general settings and all those things. Now if you want to talk about the cloud connectivity, so how the SD-WAN is going to interact with the devices hosted on the cloud, how SD-WAN is going to interact with the software hosted on the clouds. For this, they have this feature called Cloud on Ramp. You go on the configuration tab, you can see Cloud on Ramp for software as a service, Cloud on Ramp for infra as a service, Cloud on Ramp for multi-cloud, all those things are here. So either you can go from there or you can just click on here. So Cloud on Ramp for SaaS, to better the experience of cloud delivered application, we can enable this thing called Cloud on Ramp for software as a service. To connect our SD-WAN with the cloud hosted infrastructure, we can use this thing called Cloud on Ramp for infrastructure as a service. If you are using like multiple clouds, in that case, we have this Cloud on Ramp for multi-cloud. So here we can have like AWS cloud, we have this Azure cloud, we also have this Google cloud as well, like at the very end, GCP. So Cloud on Ramp for multi-cloud support, they are adding so that you can have the support of like not only AWS Azure, you can also have the support for Google Cloud. So they are continuously improving on the services. So this is a centralized vAnalytics can give you the like on-demand analysis of the entire infrastructure at in a single page. It can tell you like information related to the network. It can tell you the information related to the devices, like how many time network has gone down, on all those things you can validate with the help of this vAnalytics. So in short, let's not go in very detail of the SD-WAN, but VManage is the centralized controller. You will not get the access of the vSmart or the vBond based on GUI. It is only for the VManage, but you can clearly see that if you go on the configuration tab and on the devices tab, you can see that this VManage is in fact connected with the controllers, the rest of the controller. From here, you can see that it is connected with the vSmart, it is connected with the vBond. In fact, all these vSmarts and vBond, I can access them using SSH. I can do the configuration based on SSH, but I will not get the GUI access of them. All these devices that we have, any device, you go to the monitor tab, monitor and network, and any device, let's say for example DCVH1, okay, and just go here and control connection. You click on here and you will see that this device has connection over both the available transport, MPLS and internet. So this device, the data plane device, is connected with the management plane and the control plane over the transport such as MPLS and internet. Just to give you the brief idea about the SD-WAN, how SD-WAN works and what facilities we get in the SD-WAN, this vManage you can, this Cisco based, this dcloud based vManage you can actually explore if you want. Just so you get the idea how vManage or how this SD-WAN can be helpful in your environment. Okay, so this SD-WAN addresses those different challenges that you used to face. Like we have the support for cloud-based services, let it be software or let it be infrastructure, both is completely fine. We can do all the centralized provisioning from a centralized point as well. We can do all the configurations, management, all the day 0, day 1, day 2 operations, everything you can do from the centralized vManage. So yes, SD-WAN based on the requirement, if you have like 100 branches and you want to have a centralized control on the managed devices of those branches, you can definitely go for this SD-WAN solution. So similar to the SD-WAN technology that we have, which is responsible to manage all the WAN edge devices in your enterprise network from a centralized point, of course, with the help of some controllers. We discussed that in the last video. We also have this SD-Access technology to overcome the challenges that we were facing in the campus local area network. So to manage all the LAN infrastructure of your enterprise network from a centralized point, we have this SD-Access technology. In the SD-Access technology, the controller that we are going to use is what we call DNA Center. DNA Center is a hardware appliance. Basically, it is some appliance that Cisco sells. You can add this appliance into your infrastructure to get a centralized point of control over all the aspects of LAN devices. We'll talk in detail about that hardware later on. So different challenges that we were having, like in the LAN environment, one of the important challenges that we were having of segmentation, or we can say like security challenge, where we could use the VLANs, or we can use these different access control list. We can use the VLANs, or we can use the ACLs to create the segmentation or to control who can talk to who and what services can be accessed by the user. So to like now, as we discussed in the last videos, that using the VLAN to perform the segmentation or using the access control list to control the security in your infrastructure might not scale very well. Fine. SD-Access, in the SD-Access, when we talk about the SDA, this thing like this, instead of using the access control list, we use solutions based on TrustSec along with this ICE. your SD-WAN, like in your SD-Access DNS Center controller, can be integrated with the ICE, or you can say like ICE can be integrated with the DNS Center appliance. So ICE is going to act as this, policy plane, and from here, from the centralized point, you can ensure all the policies in your complete local area network. So, for example, what we can do is that, let's say there is a user that belongs to a finance department. There is a user that belongs to an admin department. Okay, what I can do that I can configure my SDA environment in such a way that anytime this user joins the network, the user has to be authenticated first. After the successful authentication, then the user can be assigned a tag value, some sort of tag it can be assigned. We call that as GT tag. We'll talk about that in detail as well later on. So what can be done that after successful authentication, the user can be assigned some sort of tag value. Similar to that, when the admin user joins in, let's say the tag value that is assigned to this finance user is 15, and later on when the other user joins in connected on the same switch, for example switch number 1, this user joins in. Since this user belongs to, once the user provides its username and password, the device is going to identify that, okay, this belongs to the admin group, and the users in the admin group are going to be configured with some different tag. Let's call that tag as 20. So what we can ensure from here is that any user, anytime when it joins the network, it will be assigned with some sort of SGT tag. And later on, from the DNS Center appliance, we can create a policy in such a way that we can restrict the communication between the users having the tag value 10 and having the tag value 50. So instead of doing the matching based on the criteria that ACL could match, we can simply do that matching based on the tags, SGT tags. We'll talk about the SGT tags later on. So we will not need to manage complex access control list. We can still apply the ACLs if you want, but we can also enforce the security based on these SGT tags. This can be done with the help of ICE and this TrustSec that we get when we integrate DNS Center appliance with these ICE engine. Fine. This is one of the challenges that we were having. This DNS Center appliance can deal with that challenge. Now, other challenges that we talked about, like we might have challenges associated with the deployment of new devices. Okay, we might be trying to deploy some new devices, and same set of VLANs and everything we have to configure on all those new devices as well. So what can be done in this case? What can be done is that we can create again from the DNS Center appliance. We have two things. We'll talk about that as well later on. One thing that we have is a network data platform, and we have something called network control platform. What we can do from the DNS Center appliance, we can push whatever configurations we want to do on all those devices from a centralized point to all the devices that we have added just now in the fabric. So we do not need to actually go and configure the VLANs, for example, on all the switches by administrative configurations or manual configurations. Even in fact, let's say we can stretch the VLAN 10 here. We can stretch the VLAN 10 from this access layer device to this access layer device, and in between there could be like a lot of other devices as well. So user in VLAN 10 can communicate with the user in VLAN 10 here as well. This stretching can be done with the help of something called VXLAN. This is one of the technology that this SD-Access uses within its operations. So we can VXLAN provide some sort of encapsulation method to send the data from one of the switch to the other switch. We can use VXLAN at the data plane, and we can use something called LISP, locator identity separation protocol, at the control plane to make the things easy, to push all the things from a single point. So network data platform and network control platform, these are two things. We'll talk about them later on as well in detail. So using these two things, we can ensure that all the switches that we have in our fabric have the similar set of policies. Fine. So deployment will even, in fact, we can do all the provisioning from the DNS Center appliance itself. You don't even need to touch the switch that you are going to deploy. You just have to connect it into the fabric, and all the configuration can be provisioned from the DNS Center appliance itself. The DNS Center appliance can discover the new devices. It can push the configurations on those new devices as well. Okay. So these type of deployment related issues, the deployment related issues can be solved from here as well. Fine. Other challenges that were associated in this case, such as different operational challenges are related to the operations of your existing infrastructure, where we talked about, like, for example, some user is saying that it is unable to get the IP address from the DHCP server. So this network data platform that we just talked about, this network data platform, it can also collect the data from, you know, all these endpoints and all those devices, and it can provide you after you know, careful analysis of the data that it has collected. Its AI engine and all those things are going to run in the background, and it can provide you suggestions based on which it can also provide you the suggested configurations based on which you can try to perform troubleshooting from the DNS Center appliance as well. Even if you want, like, to do the configurations, it can push the necessary configurations to resolve that issue as well. More like it is going to give you some sort of telemetry and insights of your entire network from a centralized point. You can observe different types of issues that you have in your P1 issues or P2 issues. We'll talk about that. So you can check all these different issues that are ongoing in your infrastructure, and this is going to provide you some insights about those issues, like where the users are facing those issues, what actions can be taken to overcome those issues. Okay. This all is going to be provided in some sort of user interactive way, so that the user can interact with the appliance, and the appliance can then further on push the configuration to the devices. So this SD-Access solution can also deal with variety of operational challenges that you face in your infrastructure as well. With the help of this DNS Center appliance, with the help of this SDA solution, it is possible to have similar set of, like, wired and wireless policy. We can manage these wireless access points that are there in my infrastructure from a centralized point as well. We could have, like, same policy for wired and wireless users. We can have a different policy for wired and wireless users. We can set all those policies from the centralized point itself. So management of these wireless devices in your infrastructure is going to be comparatively very easy itself. Fine. Now, other challenges that we were having, like, for example, the vendor lock-in issue. You can use different vendors, and the DNS Center appliance, basically, if you are not having a device that is capable of doing or capable of being managed from the DNS Center appliance, we can still use these old techniques such as SSH, SNMP, all those things we can use to manage those devices as well. Fine. So all these challenges that you were facing earlier can be resolved using that DNS Center appliance. So let me, again, just like in the SD-WAN section, let me show you how this DNS Center appliance look like, how its GUI is there, and what things you can do from this DNS Center appliance. So again, you had to do the same. You had to go to the D cloud, same. You search here this time, you search the DNA. Again, same thing like instant demo and all those things. You search the DNA. Here you will get the DNA assurance demo. You can get the like automation and assurance instant demo. Let me open this one. It is for version 2.2.8. Fine. So let me just open this one. I will click on view. Again, if I have to see any sort of document related to login and everything, so I will just click on related document and demo guide, and I can take a look at here as well. So this is the GUI of that DNS Center appliance. Again, we will have only view level of access. You can take a look at this diagram and you can take a look at this document and you can check the getting started guide to get the user ID and passwords. Okay, right here, same password that we had for the SD-WAN. So once you log in there, demo and all that, once you log in there, you will get this type of graphical user interface for the DNS Center appliance. So recently what they are trying to do is that they are trying to have the similar type of graphical user interface for all the devices. Earlier, if you covered the SD-WAN section like 2-3 years back, you must see that the graphical user interface was a little bit different. Even if you see this DNS Center appliance, the older DNS Center appliance, the graphical user interface was a little bit different in 1.3, 1.4 versions. Here we have a different graphical user interface for that DNS Center appliance. So this is how the DNS Center appliance is going to look like that. This is the GUI of that DNS Center appliance that we have here. Again, I have logged in with the demo user. So from here again, you can see how many sites are there as per the Feb 10, 2022. It is like 62 sites are there, 2 DNS server, 1 NTP server. Total 113 devices are being managed from this centralized point. 1 application policy is running. 897 images are uploaded. Oh, I should not have clicked there. So 97 devices are there. Now 97 images are there. 18 different network profiles are there. 1 for routing, 4 for switching, 12 for wireless and all those things. Authentication and everything. There are 97 devices which are licensed with DNA license. Okay, 45 switches, 14 routers, and 38 wireless devices. So this is just the network snapshot. How many number of devices and all those things are there. And here we have the tools that we can use to discover the network, discover the topology, see commands, and all those things. So this is the main page that you get here. Now you click on again here, and you will see that you can do almost everything that you can do using CLI from this GUI as well. So things related to the design, for example, you can check the network hierarchy, you can check the network settings, image repository, network profiles, authentication template, so that when the user joins, what authentication policies have to be applied for that user. All those things you can see from this centralized point. So let's for example go for network hierarchy, and you click here. You can see that what they have done is that they have created these different sites all across the globe. So in African region, Asia, Europe, North America, South America. So they have just created these. They have not created any sites under this one. So under the Africa region, they have Egypt location, they have South Africa location. Under the Asia, they have like China, Japan, Korea. Under the Europe, you will see that they have this England, France, Germany. So they have created all these sites here, but nothing is there under those sites. However, in the North America, if you expand this, they have like Canada location, they have Mexico location, and they have USA, obviously. So USA, you click on USA, and you can see that in USA they have different like California, New York, Texas, Washington. So they have some sort of hierarchies there. So under the global, North America, USA, California, or New York, you can check like how many, what is the information about that particular site. So if you click on here, this is the address and everything that you can see. You can click on the edit building. You can click on the edit building. You can change all those parameters from here. Again, you can click on view devices so that all the devices you can see, view settings so that all the settings you can see. So from here, actually you can see all the devices that are attached in the New York location. Fine. So that was just the main page. That was just the main page that they had there. Now, again, just like just like I said, I might not have the entire like full level of access. So I can see all those things from this centralized point as well. Fine. Now let's go on the again same tab, and from there I can, you see all these devices are there. Now it has shown me the list. This is all the devices that are there that are attached onto that particular location. Fine. If you want to check the topological view, you can just click on here and it will show you the topology view. It might take some time, but it will show you the topology view. Anyway, let's not wait that much. Anyway, we are going to do that later on, so you can ignore it for the moment. Okay, so anything related to the design, you can do it from here. You can create different network profiles. Here you can define different policies accordingly. Authentication templates you can define on here as well. So everything related to the design, you can do it from here. Now, policies, you might want to apply different policies. For example, the thing that we talked about, group-based access control using SGT tags. Okay, so you can just click on here and you can see ICE is successfully integrated. ICE is successfully integrated with this DNS Center appliance. So all I had to do, if I want to apply some sort of policy, all I had to do, I have already defined that if any user joins in and if the user provides a user ID and password to be like ABC and XYZ, the user is going to be considered part of admin group. Okay, and it will automatically be allocated with a secure T group tag value of a scalable group tag, security group tag or scalable group tag of 10, for example. And now all I have to do is that if suppose I want to block the communication between two particular users, for example, I don't want my developers to communicate with let's say contractors, okay, for example. So or I want these developers to communicate with the auditors, or I don't want to communicate with these auditors. So all I have to do is just click on here and I can just enable or disable the communication right from there. I don't have to create a complex access list to manage the traffic or all those things. I'm not saying that I cannot apply that. I can apply the policy based on IP based access control. IP based access control policies, I can apply that as well. But if you want, you can apply the policies based on that tag value that you just decided. So go under the policy, you go under the group based access control here. You can create these scalable groups that the auditor is going to be assigned with the tag value of this one, like bring your own device with this one, cameras with this one. You can define the tag values from here. You can define these, you can create these scalable groups. You can define the tag value, you can define the descriptions and everything. And then later on, you can define the policies for the same as well. Rest, we'll talk about like these things in detail later on. Fine. So there are 26, in summary, there are total 26 scalable groups, 21 ICE profiles, and 6 Stealth Watch host groups in this DNS Center appliance. Okay. We can create the policies related to the applications under the application policy. Applications, we can create the application sets and everything. So we can create the policies based on the application from here as well. Later on, when we explore this DNS Center appliance, we'll talk about that in detail. We can create different virtual networks, VMs related, like, you know, equivalent to VRFs that we have. We can create here something called VM, virtual networks, and we can map the users in certain VMs and then allow the communication or block the communication respectively. Fine. Now, what other things are there? What other things are there apart from the different policies that you can apply? What other things are there? You can go to the provision section. From here, you can create a fabric of your network. You go under the fabric tab, and from here you can create the fabric. For example, they have created this San Jose fabric. This is the location in the San Jose location, San Francisco, San Jose location. So San Francisco fabric is there, San Jose fabric is there, and you can just click on anywhere. Like you can click on, like, for example, here, and this is the topology that you have there. This is the topology that you have there, as you can see. We have these different we have the internet connectivity, we have the managed router, we have something called like border devices, control plane devices, all those things we have. Fine. So this is the topology, as you can see. The access points, 5 unified APs, 4 unified APs are there. So you can see the topology, 4 wireless hosts are connected, some IP phones are connected. You can see it from here itself. Now, if you want to do some sort of management from here, You can do it from this side as well. You can check the details. You can check the information about that device from this point. You can change the role of that particular device. You can create the port channels, the VLANs, what VLANs are configured and everything. You can check it from here. And you can also execute some commands if you want to execute. I'm not going to do that. I might not also have the access, but anyway. So let's not do that. I don't want to lose my access to this cloud-based DNS center. Anyway, so what I'm saying that you can have this topological view. You can create your own fabric, from this fabric tab that we have. Fine. Add, right here, like add fabric or add transit peers to the other network. Fine. Under the provision, we also have like inventory, plug and play. We can upgrade the things. We can upgrade the images or all those things from the centralized point as well. Fine. Okay. What else? What else we can do from this DNS center appliance? Let's see. So again, I will go to the same tab. Here we also have the assurance thing. So remember what we talked about, that if suppose some user is facing some issue, so this like DNS center assurance engine can give you the predictions. It can tell you that what issues are there, and it can give you predictions based on those issues. So you click on assurance. You can click on health to check the overall health of the network. You can check the health of the clients and everything from a centralized point. You have like this much amount of routers, like core devices, distribution devices, access layer devices. Total 113 devices are there, and almost everyone is healthy. These, different 10 issues are there. Top 10 issues are there. So some P1 issues, P3 issues, some different issues are there. Fine. And how many issues have been reported in past 3 hours? How many issues have been reported for past 7 days? All those things you can validate from here. You can go to the network tab to check the information, assurance related information of the network. You can check the information of the clients. How many clients are there? How many clients are connected? All those things you can check from this centralized point. Okay, like this. Okay, this is just the overview. Okay, we will create a fabric. We will onboard some devices. We will see in our lab as well all those things. You can go to the application tab to check the application related information here itself. So this is assurance dashboard. Under the assurance, we have this health. We can go to the issues tab. How many issues are open? How many issues are resolved? You can check from here. How many issues got ignored? You can check it from here. All those things you can check from this DNS center dashboard, centralized dashboard as well. So for example, it says like interface connecting to a network device is down. Okay. So you click on this P1 issue. Let's click on this P1 issue, and let's see what information it gets. So you click on that issue, it will give you that interface gigabit 1/0/5 is down on the network device on this Cisco Catalyst switch. You can export these information respectively. Okay. So you can check the different issues from this centralized dashboard as well. So, just like we talked about that analytics engine. So AI based this network analytics engine is going to gather the information from different network devices, and it is going to visualize you in this type of chart. Okay. Same. We can check about the Wi-Fi related information, PoE based devices, rogue access points, and all those things. We can check it from here. Different sensors that we have connected, we can check it on here. Okay. Then we can go for the network insights. We can check the insights of the network from the centralized point again. We can check all the other things related to the network like heat map and everything, where the connectivity is there, where it is not. So range and everything, how many clients are connected to 5 GHz band on this AP, all those things we can check from this centralized point. As you can see, like it might take some time for you to get yourself familiar with all these options that we have. You might not need all these options, but anyway, it's good to know that we have all these options that we can do, all these things that we can do from here. Okay. Fine. Different like issues that we have. layer 2 loop symptoms, all those things that can be reported. You can see it on this point under the issue settings as well. Health score settings, sensor settings, and all those. You can manage anything related to the assurance from here. If you want, I can show you one more thing. Like for example, I can go to the client. Okay, let's take the access of any client. So let's take the any client. Let's click on any client. Like for example, let's click on this client here. And from this client, I can do, if any issue is there, I can check the issue information from here, client ID, the OS and everything, MAC address, IP address, everything we can check from here. Okay, how the onboarding has happened, you can check it from here. So what happened that this user from from his iPad joins this particular SSID, got connected to the access point, and it is being managed from the WLC. So those things we can actually see here, that how all those things have happened. Okay, you see re-authentication and everything, all the events that have happened from that device, you can validate all those things from here. Oh, we can also run a path trace from here. So let's say new path trace, and where we want to go, we can ping all these destinations that we have here. Let me ping any destination. So let me ping here. Okay, and let's choose. Let's not choose any protocol. So let's start the trace from this machine to this particular IP, and let's see what happens. So you can click on start. If I have the access to that particular section of the view part, I will be able to see the trace properly from here as well. So what I'm trying to say is that we can also do the tracing and everything from this DNS Center appliance. Fine. It will give you the result of the trace sooner or later. And if any time the trace gets dropped, you will see that the trace is getting dropped, and you can try to troubleshoot the things based on your requirement. Okay. Fine. So what else we have? We can define the workflows from here, from the centralized DNS Center appliance as well. For example, workflows related to integration of different things such as umbrella. So we can create, we can check the workflow related to the site-to-site VPN, how we can deploy the site-to-site VPN. Let's say you do not know how to deploy the site-to-site VPN. You can just click on that workflow. You can click on here and you can define the VPN name, site names, and all those things. And you can try to, it will just guide you. It will guide you in a wizard going through which you can actually set up a site-to-site VPN, for example, in our case. Same thing we can do for the other things as well. Different other things, we also have this workflow. Okay, so we can check the things from this workflow section of the DNS Center appliance as well. Fine. What else we have here? We also have things. We have different variety of, like, we have variety of tools to discover the network, the topology, template editor, license. So how many devices are there with the DNS Center license, and all that information we can check from this tool section of the DNS Center appliance as well. As you can see, there are 58 devices with the license. So purchase like Cisco DNA license, like 58 devices in total. 18 devices are running DNA Advantage license, and 40 devices are running DNA Essential license. And out of these 58 licenses, we have like 45 licenses in use on switches. If you go on the router tab, you will see the information related to the router, WLC, for ICE, all those things we can see from here. All the licenses you can validate from this where those licenses are being used, you can validate it from here. So regarding everything related to the license, you can check from this tool section. You can also discover the new devices. You can discover the new devices based on CDP. You can discover the new devices based on the IP. All those things you can do from this centralized point. You don't even have to configure anything on the device. It can discover the newly added device in the network from this discovery tab itself. Other options are there as well. Under the platform, you have the overview, manage, deployment kit, developer kit, and runtime dashboard. All those things you can check from here itself. So overview of this, like different bundles that have been installed, runtime dashboard, configurations, all those things you can check from here. You can go under the activities tab. You can check the audit logs. You can check the tasks. You can check the work items and all those things from this activity tab in the DNA center. Reports that you have generated, all those reports you can validate from the centralized point as well. You can go for the system related information on here, like you can go to the settings and you can configure different things such as PNP or smart account credentials, ICE integration and all those things, umbrella integration and all those things. In fact, let me show you one thing. In fact, we also have the option to integrate the VManage in the newer DNA center appliance as well. And here, if you see, they are already they have already added some DNA center in this some VManage in this existing DNA center appliance. So all those things related to the management, you can see, you can define the users and their role. You can create different, just like I have logged in with the demo user, you can create different users and their roles respective to their requirements. So all those things you can check. You can you can check the release notes and everything related to the design, policy, provisioning, assurance, workflow, platform, system. All those things you can do from this centralized point. So this is how your DNA center appliance looks like in the GUI format, and this is how you can do all those things from the centralized point. We'll talk about that in detail, how to add the devices, how to create the network, everything later on. But this is the centralized dashboard to manage all the LAN devices from the centralized point. All right, so next concept that we have is underlay and overlay. We will use this term underlay, overlay a lot in our SDA network. So let's clear what is underlay, what is overlay. To understand this, consider this diagram. So here in this diagram, we have few devices. We have this access layer device, access layer switch 1, access layer switch 2, access layer switch 3, access layer switch 4. Maybe these could be in a single building. This could be in a different building. This could be a different building. But consider these are all the access layer devices. These are two distribution layer devices. We have aggregated the access layer devices into the distribution layer. Here also we have one distribution layer device, and all the distribution layer devices are aggregated at the core. This is core layer switch 1 and core layer switch 2. Now in a typical environment, this is what you will see, that a network is going to consist of these three layers, these three, you can say, access layer, distribution layer, and the core layer. Access layer is where the end users are connected. Distribution layer is the aggregation point for the access layer devices, and the core layer is where the distribution devices are aggregated. Now, let's say there are two users in this access layer. At this access layer is on this switch number 1. Let's say there are two users. One user is in VLAN 10 and the other user is in VLAN 20. Just wait a minute. Now. Okay. So there is a user in VLAN 10 and this is a user in VLAN 20. Now, in the second floor, this is the first floor of the company. Let's consider this as the first floor. This is the second floor. This is the third floor, and this is the fourth floor. So on the second floor also, there is a user in the same VLAN 10 and the same VLAN 20. Like here in the third floor, there is a user in VLAN 10. There is a user in VLAN 20. On the fourth floor also, user 10, 20. This is the second building, first floor, second building, second floor. So we have users in VLAN 10, 20. Now our requirement is that the user must be able to communicate, like VLAN 10 user must be able to communicate with VLAN 10 and 20 must be able to communicate with VLAN 20. So, one VLAN is equal to one broadcast domain. We already know it from the basic studies that one VLAN equal to one broadcast domain. So as soon as we created multiple broadcast domains here, we created multiple VLAN, means like we created multiple broadcast domains here. Now, what I want to do, I want to extend this VLAN 10 broadcast domain all the way up to second floor, third floor, fourth floor, and then onto the second building as well. Second building, first floor, and second floor. So what we can do is that we can extend the broadcast domain of VLAN 10 over these links using this concept of trunk. We can configure these links at the trunk link. These trunk links can now forward the traffic for VLAN 10 and VLAN 20 on all the second floor, third floor, fourth floor, and then this could be a layer 3 network. This could be the aggregation point for the layer 3 and layer 2. So the traffic can from here it can go to the distribution layer. From the distribution layer it can go to the core layer, and from the core layer it can go to the distribution layer. Basically, it could be routed. Here, routing will take place. So packet that will arrive on this distribution layer switch 1 will be routed towards the core layer switch, and then from core layer switch it will be routed to the second building, the distribution layer, and from there it can go to the VLAN, like using the trunk, it can go to the VLAN 10 and 20 respectively. So the one way to extend the VLAN from one switch to other switch over this network is by using this thing called trunk. This is how the traditional networks are built in typical cases. Now there are a lot of challenges in this is a layer 2 bound network. This is a layer 3 network. Here we are using routing, and here we are using switching. Now the challenge that you will face here, one of the challenges that you will face here is that we have connected like multiple cables, like from this access layer switch 1 to distribution layer switch, we have one cable. We could have multiple cables here as well. So as you can see here, since we are running, we have connected these switches via multiple cables. Protocols such as STP, VTP, DTP, these protocols will start running as well. They will create some overhead traffic, but these protocols are necessary so that, for example, like STP is necessary because layer 2 loops, they do not occur. Fine. This is how the traditional network is built. When we talk about the software-defined network, this is not exactly the same. In the software-defined networking, this entire campus fabric is based on layer 3. So up to this point, like everything is going to be on layer 3. Like this all is layer 3. Routing is running. Here we still have VLAN 10, VLAN 20, 10, 20, same thing. We have VLAN 10, VLAN 20 on all these devices, access layer switches. Let's still call them access layer switches. But now the challenge is, if it all is layer 3, how we are going to extend our VLAN 10 broadcast domain from here to here? How we can extend our VLAN 20 broadcast domain from one building to the other building? Fine. So since in a software-defined approach to manage the LAN infrastructure, this entire network is layer 3, just using the trunks and everything is not going to work. We cannot use trunking in this case to extend that or stretch that VLAN from one switch to the other switch. We need some other technique so that we can extend or we can stretch the VLAN 10 of this switch all the way up to maybe from here to here. I want to send the traffic from this machine to this machine in the same VLAN over this layer 3 network. Fine. This is one of the example. This is one of the example. How we are going to achieve this? We are going to introduce something called overlay in this topology. Now this infrastructure that you see, this cable, switches, all these devices that we have connected, this all is going to serve as something called underlay. Underlay is the underlying physical infrastructure on the top of which overlay is built. Overlay is a complete logical network. Overlay is a logical network built on the top of the underlay. What we can do is that we can create some sort of tunnels. Overlay uses this concept of tunnels. We can build a tunnel from switch 1 all the way to this second building, first floor, switch 1, and I can send my traffic over that tunnel, which is built on the top of that underlay layer 3 network. So underlay is a logical network built on the top of the Underlay. Overlay is the logical network that is built on the top of underlay. Underlay is the physical infrastructure that serves the overlay. Under this underlay network, we will have like these different switches. We have the physical connectivity. We do have some protocols running. We might run any protocol here, like we might run OSPF routing protocol. In SDA, it is preferred to run ISIS protocol. They say that you run ISIS protocol. Okay, this is one of the example that you can take. Another example of the underlay and overlay you can think of. Let us consider again a similar scenario. Let's say we have a few routers here, and we have our LAN subnet here, which is 192.168.10.1. Here we have a LAN subnet here, 192.168.20.1. Now this infrastructure is not under our control. Like this infrastructure is not under our control. You can consider it as some sort of service provider network. This is one device in Delhi location. This is one of the device in, let's say, Mumbai location. We have taken the connectivity from one of the service providers. So I do have connection. I do have the connection. I do have the reachability from this point to this point. Now what I want to do, I want to send my traffic from 192.168.10.1 to 192.168.20.1. But I cannot just simply do the routing, because first of all, this is a private subnet. For the private subnet, private subnets are not allowed on the public transport, such as, it could be any transport such as internet. And if, consider yourself a customer, if just like you, if this service provider has like 1,000 customers and every customer starts advertising the route, in that case, you will see that these routers will have to maintain like a lot of routing information. So provider will say, no, I'm not going to allow you to advertise any route. I want the reachability from 192.168.10.1 to 20.1, but I do not want to advertise these destination information into the protocol that we are running. Why? So that this service provider don't need to maintain all those routes in its routing table. And of course, I don't want to add any sort of overhead on these core routers as well. So what we can do, we can again take we already have the reachability from my Delhi to Mumbai location device. So what we can do, since we have the reachability from this point to this point, this entire network can serve as an underlay, and I can build a logical network on the top of this underlay. I can build a tunnel from one point to the other point, and I can send my entire traffic over this logical tunnel that I just built from Delhi location to this Mumbai location. It could be any protocol we can use to build this tunnel. There are very popular protocols such as GRE we can use to build a tunnel. GRE, generic routing encapsulation, is one of the protocol that we can use to build these tunnels, and then we can do the routing, and then we can send the traffic from 192.168.10.1 to 20.1. It would look like that the traffic came from 192.168.10.1 to this router, and from the router it was sent via that tunnel all the way to the router number 2, and from there it went to the LAN destination. It would look like the traffic is going directly from this router to this router. However, the traffic actually is passing via that underlay. Now, how these devices are not going to identify, how these devices are not going to know that the traffic is passing from 192.168.10.1 to 20.1, because whenever we pass the traffic over any sort of tunnel, some extra encapsulation takes place. Some extra encapsulation is going to take place. That is, extra encapsulation will be done by, in this case, GRE itself. When we talk about the SDA, we use that something called VXLAN concept, virtual extensible local area network, to do that extra encapsulation on the data passing from one device to the other device over that underlay. So the tunnel that is built in here, it is based on VXLAN. The tunnel here that we have built, it is based on GRE. What is going to happen when this device sends the traffic? this device will create, let's say this device creates an ICMP packet. In that ICMP packet, it is going to add some sort of IP header. That IP header will have the source IP as 192.168.10.1, the destination IP as 192.168.20.1. Then over that IP packet, since the packet has to go via GRE, GRE is going to add its own header, and then it will add a new IP header, and that IP header will have a new source IP, which is this IP address, tunnel source. We define it in the configuration. Okay. We define it when we do the configuration of GRE. So this IP address, let's call that 1.1.1.1. So this IP address 1.1.1.1 will be the source IP, and this IP address right here is going to be the destination IP, which is 4.4.4. So now, and then again the Ethernet header and Ethernet trailer will be added. So when the packet now arrives on this service provider router, it would look like that the packet is going from 1.1.1 to 4.4.4, which are public destinations, and this service provider router can forward the packet from this interface to this interface. This router is going to take a look at the routing table, and again it is going to forward the packet towards 4.4.4 here. Then this router is going to decapsulate that packet, and it will come to know that, oh, it is a GRE packet. So I have to take a look at the destination IP address inside the IP header, and then the packet will be forwarded towards the correct destination. So even though the packet is traveling from the actual underlay, it looks like the traffic is going from the endpoint to endpoint directly because of that extra encapsulation that is happening. Fine. This is again one more example. This is very beneficial. Similar to that, we do have services such as MPLS. We can have this MPLS service provider network, where here we have a router. We have taken the service from the service like MPLS service provider. They have given us a connection. I can give all my routes information. I can give all of my routes information to provider router, and this provider router is going to send all that route information to the other side. We call that provider S2. From there, it can go to my second location. So logically, I can exchange the route from one point to the other point, and in between all these routers, they do not need to know the destinations. They do not need to maintain the information about all these routes that I have just exchanged. BGP protocols such as BGP can easily do this task of exchanging the route from one provider is router to the other provider is router. So whenever the packet arrives here, it will look like the packet has to go from this router to this router directly. And MPLS is going to perform the encapsulation again, like labels and everything is going to be added over the data. And based on that extra information that is added, the packet will go from this router to this router, and then all the way through the MPLS cloud to the exact destination. So underlay is the underlying infrastructure on the top of which overlay is built. Overlay is a logical network which is built in between any two devices where we have the reachability. So how we are going to form the reachability from this device to this device? We will have these links configured as the layer 3 link. Now, as soon as we configure these links as layer 3 link, we will not have any requirement of protocols, layer 2 protocols such as STP, DTP. These protocols we would not require because these are purely now the layer 3 links. We will do the routing, and the routing to make these switches reachable to each other will be done based on protocols such as OSPF or ISIS. Cisco recommends that in SDA solution we use ISIS, not OSPF. And once the reachability is there, a logical tunnel can be set up based on technology such as VXLAN. A logical tunnel can be set up when we have to forward the data from one point to the other point. In that way, users can be on the same VLAN, like VLAN 10, no matter how many number of switches are there in between, and we don't have to stress the VLANs on these switches. They are not even aware that those VLANs exist. These are pure layer 3 devices. This is what we can achieve in software-defined networking under the SDA. When it comes to SD-WAN, although it is not our curriculum, in SD-WAN, this thing is done using IPsec. As soon as one VManage router comes to know about the other VManage router, it automatically forms some sort of IPsec tunnel, and within the protection of that IPsec tunnel, it exchanges all the data. So there are also some sort of tunnels are used to exchange the data from whatever type of transport network it could be. Like we can have internet as a transport network. We can have MPLS as a transport network. We can have 4G LTE as a transport network. No matter what transport it is, till these IPs are reachable, we can form a logical tunnel between them. Your physical network will look like this, but your logical topology will look like something else. It would look like that those two devices are directly connected, and we can send the data from 10 to 10 and 20 to 20. So underlay consists of these devices, wiring, cabling, and everything. Underlay is the infrastructure, and overlay is the logical tunnel that is built on the top of underlay. I hope you understand this concept of underlay and overlay. All right, so before going any further, let's talk about some architectural components of the device, which could be very beneficial in the later part when we talk about the control plane and the data plane in the SDA. So if you segment the functionality of a device, we get a total of 3 architectural planes, or we call them planes of operation. You can segment the functionalities of the device, or you can segment the operations of the device into 3 categories. And each of these 3 planes of operation, they have very specific and clearly defined objective. So one of the architectural plane that we get is something called control plane. Control plane of the device is the brain of the device itself. Like it consists of all the control plane operations, all the functionality that the device performs, such as routing. It consists of like variety of protocols such as OSPF, ISIS, BGP. It runs the protocols such as ICMP, ARP, IGMP, and all these protocols. The control plane is basically responsible to maintain variety of tables, such as it is responsible to maintain the routing table. It is responsible to maintain the ARP cache. It is responsible to maintain the STP database and everything. It is responsible to maintain different types of other tables that could be present on the device. Anything that goes towards the device, we can say that it is going towards the control plane of the device. Any operation that is CPU intensive operation or CPU centric operation, we can say that it is done by the control plane of the device itself. All the routing protocols that we have heard of, like for example, let's say we have to exchange some route information between router 1 and router 2. So we run protocols such as OSPF. So OSPF messages get exchanged, some sort of adjacency is established, then the subnet information is exchanged and a routing table gets updated. So who is going to generate the OSPF messages? Who is going to send those OSPF messages? Who is going to maintain the routing table, keep the entries in the routing table, flush the entries from the routing table if the route gets invalid and everything? All that responsibility goes towards the control plane. So control plane of the device is basically the brain of the device itself. Anything that goes towards the device will go towards the control plane. Okay. So in traditional cases, in traditional devices, there is a general purpose CPU. There is a general purpose CPU which is responsible to manage all the control plane functions. All the control plane protocols run on that general purpose CPU. This happens in a centralized architectural platforms. Like in whatever devices we have a centralized architectural platform, this general purpose CPU is responsible to do all those things. We do have some devices that follow distributed architectures. Okay, where we have something called in distributed architecture. In distributed architecture, we have something called route processor, or we call them supervisor engine, which is responsible to do all this CPU intensive task. And all the protocols run under, like major protocols run under this route processor or supervisor engine. How some protocols run here, and some protocols such as ARP, such as BFD, ICMP, they are now sent to the line cards of the device. They don't run on the centralized route processor engine, but that is limited if your device has a distributed architecture. In your distributed architecture, we have supervisor engine, we have line cards. You might see the distributed architecture in high-end switches. But in a centralized architectural platforms like normal routers and switches, you will see there is a general purpose CPU which is going to manage all the control plane functions. Okay. Now, when it comes to the data plane, second operational plane, second architectural plane is something called data plane. Data plane is the actual point from where the data is transmitted from the device. So anything that goes through the device, it is going to go from the data plane. Data plane is the plane that is responsible to do data forwarding. We call that forwarding plane as well. It is responsible to switch the packet from one interface to the other interface. Actually, it handles things like encapsulation, decapsulation, all that thing it handles. In the data plane, we can apply different types of feature that could affect the forwarding behavior, such as we can apply something called access control list, such as we can apply quality of service. Applying the access control list or quality of service, we can control what packets can pass, what packets cannot pass with the help of the access control list. And we can give some sort of preference to the devices, to the packets which are being passed through that particular device. So the data plane is the part of the device which handles actual data forwarding. Anything that goes through the device, it goes through the data plane. Now, when we talk about forwarding techniques, in older times, we had something called process switching. We had something called fast switching. And nowadays, in Cisco devices, we have this thing called CEF, Cisco Express Forwarding. What used to happen in the process switching? Anytime a packet arrives on the device in the data plane, the packet will be sent towards the control plane. Control plane is going to do all the lookup and everything, and then it is going to instruct the data plane that okay, you have to forward the packet out of this interface, and then the data plane is going to do necessary encapsulation and forward the packet out of the interface. So packet arrived on FA0x1, packet was punted, packet was sent towards the control plane of the device. In the control plane, we have that variety of tables like routing table, we have the ARP cache and everything. From there, instructions were passed to the data plane, and now the data plane is going to switch the packet from one interface to the other interface based on the instructions that it has received. This is what used to happen in the process switching. Then they introduced something called fast switching. In the fast switching, what the device does is that it is going to maintain some sort of cache memory. So first time when the packet arrives, it is process switched. Means the first packet will go towards the CPU. From the CPU, routing table, ARP cache lookup will happen, and then the instructions will be passed to the data plane, and the packet will be encapsulated and switched out of the appropriate interface. But CPU is also going to maintain a shortcut entry in that cache, so that if I send the same, if there are some subsequent packets, if I'm sending the packet to the same destination, I don't have to send the packet towards the control plane again. I can just refer to that shortcut entry and I can switch the packet from one interface to the other interface. Fine. This is what we used to call as fast switching. In first generation of multi-layer switches, in first gen of the multi-layer switches, we used to see this fast switching mechanism. Route cache based switches, those were. Route ones, switch many. Later on, this CEF technology, Cisco Express Forwarding technology, was introduced. This CEF technology is going to maintain two tables in the data plane. One is called forwarding information base and one is called adjacency table. So whenever the packet arrives, packet is going to look up the fib table. From the fib table is exact replica of routing table. We call that routing information base. In fact, better replica of the routing table is this fib. So the entries will be checked in the forwarding information base table. Then from there, the appropriate exit interface will be selected, and then the packet will be placed out of the appropriate exit interface. Whatever encapsulation has to be done, that information, what MAC address will be added as the source MAC address, destination MAC address, ether type, and everything, it is maintained in the adjacency table. So even for the first packet, the packet will not go towards the CPU. And all that information like cache and these two tables are maintained in the data plane of the device. So data plane is the part of the device which is responsible to do actual data forwarding. And the third and the last architectural plane that we have here, third plane, is what we call as the management plane. Now the management plane of the device is responsible to see how the device is being managed, how we have taken the access of the device. Are we connected to the device using console? Are we connected to the device using VTY, remote access, or auxiliary? How the device is being managed. Are we using any sort of SNMP protocol? Are we transferring some files from the device? Have we used telnet, SSH? So the device management is the responsibility of management plane. Now there could be in-band management, out-band management, that is the other thing, but management plane is generally responsible to manage the device through the connection to the network. There could be different protocols used for this task, such as SNMP, FTP, SFTP, SSH, telnet, all these protocols. You can connect console cable directly to the device. You can connect the console cable to the auxiliary port of the device. You can do the device management using different concepts, different lines that we have on the device. Line console, line VTY, line auxiliary. We can also use the protocols such as SNMP to do basic device management. Okay. Now, so these are three architectural planes. We have this thing called control plane. Okay, we have this thing called data plane, and we have this thing called, let's call that management plane. Okay, we have these three architectural planes of the device. Every architectural plane has its own set of responsibilities. Management plane is generally concerned with the device management, how the user has taken the access of the device, how the device is being managed. Data plane is responsible to do actual data forwarding. So packet arrives and packet is going to exit out of the appropriate interface. So what encapsulation will happen when the packet exists out of the interface, how the packet is going to be decapsulated and everything, it will be handled by the data plane. Control plane is responsible to do everything related to maintaining variety of tables which could be used in data forwarding process. Control plane controls the data plane. Control plane controls the data plane. It tells the device how to forward the packet going towards a certain destinations. Now, in a device, all these things are within the device itself. We could have centralized architecture, we could have distributed architecture, that is a different thing. But if we talk about, let's say we have 3 routers here, and we have to configure some protocols on these 3-4 routers. Why we have to configure the protocol? So that these LAN subnet information gets exchanged. Okay, so what we have to do actually, first of all, I have to take the access. I have to take the access of this device. Then I will run whatever protocol we are going to run, such as maybe we want to run the OSPF protocol to exchange the route. And once the route gets exchanged, then we can do the data forwarding. We can do the ping trace that we want to do. Now, once we are done doing this, then I will disconnect the cable and then I will connect it again on router 2. I will do the same thing here. Then I will do on router 3. I will do the same thing. Then I will do on every device has its own set of control plane, management plane, and data plane. That's what I'm saying. I'm saying that every device has its own set of control plane, management plane, and data plane. That is why every time you have to do some sort of configuration, you have to take the access of these devices one by one. It's not like you configure OSPF here, it will automatically exchange the route everywhere else. Like we don't need to configure OSPF here. It's not like that. We have to configure OSPF on all the rest of the devices as well. So we have to run some sort of control plane protocol, which is responsible to exchange the route information in between the devices. In our case, OSPF. And then finally, the data forwarding will take place. And also, this device cannot forward the data by looking at the routing table of router number 2. Router 1 can look its own local routing table, and then it will do the data forwarding based on that. It cannot refer to the routing table of router 2, router 3, or router 4. Every device has its own set of control plane, management plane, and data plane. And that is exactly where the problem exists. What if the control plane goes down? What if the control plane of the device goes down? Everything is on the same device. What if the control plane of the device goes down? What if I cannot take the management access of the particular device? Since this was some sort of centralized architecture, like distributed architecture, like everyone is having its own set of control, distributed in that term that everyone is having its own set of control plane, data plane, and management plane. Whatever management related task we do on here, it will not make any impact on here. So when we introduced or when we use the software defined approach to manage the LAN or WAN devices, what we generally do, we separate these management plane, control plane, and data plane functionalities from the device. For example, if we talk about SD-WAN technology, which is a technology to manage all the WAN edge devices. In SD-WAN, the control plane of your network is centralized with the help of a controller called vSmart controller. What they thought that if I have a distributed architecture where everyone is having its own set of control plane, I have to configure the protocol on everywhere. I have to troubleshoot why the protocol is not forming the decencies on everywhere. So instead of having a distributed architecture, they thought of having a centralized control plane. So, and they created a controller which is responsible to do all the control plane related tasks in your network. Everything that you can do related to the control plane can be done using this controller called vSmart controller. Management plane, when we talk about the management plane, I want that all the devices, I should be able to access all these devices from a centralized point. So that is now done with the help of something called VManage Network Management Station. This is also a controller in SD-WAN. There is a controller called VManage NMS, and this VManage Network Management Station is responsible to centralize all the management related tasks. Then we have the data plane. All these devices, all these routers like Viptela, V stands for Viptela. So Viptela operating system based S devices or Cisco operating system based S devices. Routers, typically these are just routers. These are routers. So all these routers, they are just now the data plane devices. They should know who is the management plane. They should know who is the control plane of the network before they can be considered as fully functional. So in SD-WAN, they follow this centralized architecture where they have the control plane based on vSmart, they have the management plane based on vManage, and they have the data plane on the S devices itself. When we talk about the SD-Access, the centralized, we'll not say centralized basically, the control plane functionalities or control plane in SD-Access is based on a protocol called LISP, Locator Identity Separation Protocol. We'll talk about that as well. I'm not going to say centralized at the moment. When we talk about LISP, we'll understand what is LISP and how is it really centralized, or we do still have like a decentralized control plane in the SDA. We'll talk about that. Since our focus was not on the SD-WAN, so we talked at this point itself like vSmart is centralized controller, vManage is the centralized controller. Similar to that, we'll talk about the control plane based on LISP later on. So in SD-Access, the control plane functionalities or control plane is centralized using a protocol called LISP. When it comes to the data plane is based on something called VXLAN, Virtual Extensible Local Area Network. So we have a data plane based on VXLAN. You might already know VLAN. To overcome the issue of stretching the VLAN from one switch to the other switch, we have this concept of VXLAN. We'll talk about that in a dedicated video as well. And when it comes to the management plane, all the management and everything is done from the DNA Center appliance itself. DNA Center appliance is the hardware appliance that you have to purchase and install in your network. And from there, you can do all the management related tasks. We do also have something called policy plane, policy and everything can be applied using ICE. ICE acts as the policy plane. There is a specific service called PX grade service. We'll talk about that as well. So policy plane policies are ensured with the help of ICE in the SDA fabric. Let's ignore the policy plane for a moment. You have to understand that the control plane is based on LISP, the data plane is based on VXLAN, and the management plane is based on DNAC. Basically, like everything you can do from the DNAC itself, but obviously the management you can do from the centralized point DNAC as well. Not only management, you get a lot of other functionalities. We have already taken a look at the GUI of the DNA center appliance, and you already know what things it can do. You have already taken a look at the VManage GUI, and you already know what it can do. So this is what they did in the software-defined networking to overcome the challenges of the distributed architecture in the network. They did not want that we had to configure the protocol such as OSPF on every devices one by one. We should have a centralized control plane for all the devices. They did not want that we should manage the every device one by one. So they have the centralized VManage NMS from where we can do all the management. We should have secure data plane from S device to S device as well. So that security is provided by something called IPsec. In SDA, the control plane is based on LISP, locator identity separation protocol. Data plane is based on VXLAN, and the management plane is based on this hardware platform called TVAC. Okay, so this is the difference between the traditional devices, traditional network, and the software-defined network in terms of architecture. Right, so to summarize everything that we have covered in the previous videos, to deal with variety of challenges that we have in our campus area network regarding WAN and LAN, the Cisco came up with the idea of introducing the software-defined networking. In the software-defined networking, they had these two things like SDA and SD-WAN. So SD-Access is a solution to manage all the devices in a local area network of the campus, and the SD-WAN is the solution to manage all the WAN devices. These two solutions together, they give us the option to control everything from the LAN and WAN point of view from a centralized point. Nowadays, even the SD-WAN can be integrated with the SDA solution so that you get a centralized GUI, and from there you can manage all the rest of the things. As far as the data center network is concerned, ECI is already there for the data center environment. Now, the SDA solution consists of several components. So the SDA solution, if you specifically talk about the SDA solution consists of several components. The heart of the SDA solution is the DNAC, DNAC appliance, DNAC hardware that you have to purchase from Cisco. It runs on the top of that EPKM hardware that Cisco used to sell in earlier days. So it runs on the top of that EPKM hardware, and the DNAC is the hardware appliance. At the moment, they have not made it virtual. At the moment, it is a hardware-based device that you have to purchase and install into your fabric. This DNA center appliance is going to have something called network control platform, and it has something called network data platform. These two things are there. This DNA center appliance can also be connected with the ICE, or ICE can be integrated with the DNA center appliance. The network control platform. From here, we can do all the things related to the configuration management. Like it is where we define our intent. Under the network control platform is where we define our content. We can say this is the automation engine for the SDA solution. From here, from this DNA center, we define our intent, and this network control platform is going to deploy our intent into the entire infrastructure. So network control platform is it handles the automation part of the DNA center. Automation in the sense that we can do the configuration, management, provisioning of all these devices from the centralized point. As far as the network data platform is concerned, it can be considered as the part providing the assurance in the SDA solution. The network data platform provides you the better visibility of your network. It provides better insights of your network. You can see what different type of traffic is flowing from your network, like what devices are healthy, what devices are not healthy, where different issues are there. So from this NDP, this network data platform is the part of the data center, is the part of the SDA solution, which is responsible to provide the better insights of the infrastructure. And based on those insights, you might try to deploy some policies to control different aspects of the network. And the identity services is provided from ICE. Like when the user joins in the network, it can be authenticated using this ICE platform, like ICE Identity Service Engine. When the user one joins, we can define that when the user one joins, it will be allocated with a tag value of 10. When the user two joins, it will be allocated with a tag value of 20. And later on, we can create a policy where 10 cannot communicate with 20, or 10 can communicate with 20 only. We can define these type of policies. Now, even though the ICE can be integrated with the DNS center, it is the DNS center that is going to manage the policies and everything. Okay, we are going to create the policies or define these tags, security group tags and everything from the DNS center appliance itself. The ICE is just connected to the DNS center appliance. Of course, they will communicate to each other, like DNA and ICE are going to communicate to each other. And these things like authentication and tagging and everything, policies and everything will be ensured. Now, other devices that we have in our DNS center appliance, these are like, for example, we have some device. We don't necessarily need to place the DNS center appliance in a specific branch, or like it's not like on per branch basis we should have a DNS center appliance. We can connect our DNS center appliance like anywhere. We can have this DNAC placed in the data center environment. And then using some transport such as Internet M+, we can connect this DNS center appliance to our rest of the fabric. So in a branch, what we can have certain devices which can be called as the border devices. These border devices are used to provide the connectivity outside the SDA fabric. Maybe your border devices are going to send the traffic to the internet or take the traffic from the internet to the campus fabric. They can be connected to some other L3 network, other non-SDA managed network as well. See, these border devices are the devices from where your SDA fabric is connected to outside of the SDA fabric. Then we have these edge devices, like let's call that S device 1, S device 2. We have these S devices here, S device 3. These S devices are the devices where our wired or wireless users are connected. So we can connect an access point, and from here a wireless user can be connected as well. So these S devices are typically switches of your SDA fabric where the S devices are connected. Now there is a device called control plane device, which is responsible to keep a track of what S device, what endpoint is connected to what fabric edge device, what endpoint is connected to what fabric edge device. It is going to maintain some sort of database, and on that database it is going to keep this information that which endpoints are connected to which edge devices. And later on, let's say if the device X wants to communicate with the device Y, the tunnels that is built between the E1 and E2, the logical tunnel that is built between E1 and E2 based on the protocol called VXLAN can be used to send the traffic from X to Y in the same VLAN, like VLAN 10, VLAN 10. We can have the tunnels from E1 and E3. We can have the tunnels, the VXLAN tunnel. These are the data plane tunnels. VXLAN tunnel, VXLAN tunnel. So data plane encapsulation, data at the data plane, the data is encapsulated with this protocol called VXLAN. We'll talk about that in very detail later on. So data plane is based on VXLAN. VXLAN provides an encapsulation method to send the traffic from one S device to other S device over a layer 3 network. Remember, we talked about that all these S devices that are connected to each other, it is going to be a layer 3 connectivity. And over the layer 3 network, we can still send our traffic from one VLAN to other VLAN. VXLAN provides us that functionality. Now the control plane node are going to maintain this information, that what S device is connected to what endpoint. Control plane is brain. You can say the control plane is your brain of the SDA fabric. It is recommended to have at least like 2 control planes, so that if one goes down, at least you have the other control plane working as well. Typically, these are routers. We'll talk about like, what routers are capable of doing this control plane functionality. Okay. And we also have these WLC, wireless LAN controller. Fabric WLC, it does not need to be part of the overlay network. In fact, Fabric WLC does not need to be connected to the SDA fabric. It can be connected anywhere, like in the data center and everything. So the WLC, the wireless LAN controller, is the point that is aware of the SDA. So from this Fabric WLC is going to provide us the management of all the access points that we have connected into our fabric. So this entire, like all these devices that we have here, like control plane node and everything, all these devices that we have here, this is part of the campus fabric. All these like border node devices, control plane devices, S devices, Fabric WLC, and they could be intermediate devices as well. Like they could be non-Cisco devices, they could be Cisco devices, they could be some intermediate devices as well. So this in the SDA solution, this is what we call as campus fabric. Campus fabric is the overlay network which is built on the top of underlay. And along with that, we have this DNS center appliance to manage all the things from the centralized point. So when we talk about the SDA solution, what components we get the DNAC, DNS center appliance, we get ICE, we get the devices, the underlay connectivity options. We have like protocols such as OSPF, ISIS. And when it comes to the overlay, in overlay, the tunnels are based on VXLAN. And the control plane functionalities are based on LISP, locator identity separation protocol. So LISP is the protocol which is responsible to manage all these functions, like what endpoint is connected to what S device. So later on, if this S device, this endpoint wants to go to this endpoint, the VXLAN encapsulation can be done properly and everything. So what encapsulation, what things must be added when forwarding the traffic from one S device to the other S device, that can be managed from the LISP. LISP is going to keep a track of all this information. Then we have like intermediate devices which are not part of the SDA fabric. We have the access points where the end users can connect. The access points and WLC can form the CAP web tunnel. We'll talk about that later on. So the overall solution in the SDA consists of all these components. We'll drive deep in the concepts of like what devices can act as the border devices, which devices can act as the control plane devices, border devices. We'll talk about that in very detail in the later section. But overall picture of the SDA is in front of you. So this is what they were trying to do when they say like the DNS center is going to be the centralized point of control for managing all the LAN devices in a campus fabric. We'll talk about all these other device roles and the layers in the SDA later on in later videos. When it comes to the SDA architecture, under the SDA architecture, we have few layers. We have the physical layer. We have the network layer. We have controller layer. And we have the management layer. In the physical layer, we have physical devices. Those physical devices can be categorized as fabric, edge node. We can have control, plane, node. We have fabric, border, node. And we have those intermediate devices which are not even intermediate node, which are not even aware of the SDA deployment. Now we have different models that can act as the fabric edge node, control plane node, border node, or intermediate node can be any device like It can be like Cisco, non-Cisco, any device. It doesn't matter if you're going to use only Cisco devices, but fabric edge node, fabric control plane node, fabric border node, these are different devices. We can combine the functionalities of the fabric control plane node and the border node into one device. However, it is not a very recommended solution, but we can do that. So when it comes to the physical layer is concerned with the physical devices, all the devices that we are going to use in our infrastructure. All those devices are going to have different roles, as we talked about. Now, the network layer is going to consist of, let me just write down here. The network layer in the SDA is going to consist of two things. One, we have underlay, and one we have overlay. In the underlay, we have again two things. Either we can have automated underlay or we can have a manual underlay. Automated underlay is provided by the DNAC, and the manual underlay can be either layer 2 or layer 3. If you are using layer 3 as the manual underlay, we have to use any IGP protocol. Cisco recommends that you use ISIS. In fact, it is what you will see in the automated underlay as well. Underlay is the underlying infrastructure on the top of which different tunnels, overlay tunnels are built. In the overlay, we have like control plane based on LISP. We have data plane based on VXLAN, and we have the policy plane based on Cisco Trust Sec. Okay. So different tunnels are created from one fabric edge node to other fabric edge node. VXLAN tunnels are created, and within those tunnels, your data is going to pass, and that is what the overlay is going to do for us. It is going to carry the data for different users from one fabric edge node to the other fabric edge node over the underlay, after encapsulating it with protocols such as VXLAN. Third, we have the controller layer. In the controller layer, we have the different controllers. We have DNAC, we have ICE, and we have the fabric WLC. In DNAC, we have two things again. We have data control platform and data platform, and DP and CP, responsible for assurance, responsible for NCP, responsible for pushing all the configuration and rest of the things to the network. ICE acts as the policy plane. From here, we can apply a variety of security related policies, and a WLC is going to manage all the access points of the network. And finally, management layer. Management layer is it deals with how that DNAC is being managed. Are we using that web-based GUI to access the DNAC, or we using some third-party automation tools such as Postman and exposing those APIs to push the instructions to the DNAC? In both the cases, it is going to use REST APIs. If you are aware of the tools such as Postman, you know the scripting, you know the APIs, how to create variety of API calls. You can directly use these tools. You don't need to open the GUI, or you can use those third-party automation tools. You can use scripting, Python scripting and all, to create variety of API calls to push your intent to the DNAC, and the DNAC is further on going to push all those things to the devices such as switches, routers, WLCs and all. So management layer is specifically concerned with how the device is being managed. Fine. So these are 4 layers that we see in the DNAC. All right. So now we are done with the basics. Now we'll move on to some more technical things such as how the control plane is based on LISP, LISP functionalities fundamentals, and the data plane based on VXLAN functionalities and fundamentals.